What is up? Daniel here with the Virtual Robotics Studio, and we're back with our second video series for the 2026 season. This time we're going to take the KitBot, we're going to put it on a Swerve drive platform. Now, there are a few things that I want you to be aware of for how we've made decisions for what modules and how we're setting this robot up. Our goal with this robot was to take the KitBot mechanisms, drop them into a Swerve drive chassis with as few changes as possible. We want to basically keep the heart of the KitBot unchanged while updating it to a Swerve drivetrain. Now, in Michigan, and I think maybe in a few other places, Across the Road Electronics and West Coast Products have donated some Swerve drive modules to teams that are going to be competing this year. So I think a lot of the second-year teams in Michigan are getting a set of Swerve drive modules. Now, we've done a video series in the past where we used the Swerve X2i setup with all Across the Road Electronics. The problem with the inverted setup is because the motors go down, that's really nice if you, for example, want to keep a low profile so you can do an over-the-bumper intake or something like that, where the motor being in the way in the middle of the robot isn't the problem. The biggest problem is trying to keep it below the frame so you have room above to build stuff. Unfortunately, this year, the way the KitBot works with the ground intake, we are losing a lot of space for that motor that's hanging down on the front of the robot. And if we widen the robot to accommodate that extra space, now all of a sudden the robot has to be very short. And the hopper on the back is going to stick way out. So we're going to have to cut the hopper way down if we did it that way. So one of the changes we're going to make is we're going to be using two of these Swerve X2Is in the back of the robot, the back two corners of the robot, because that is what is in kind of the FIM Swerve module videos that we did last year, and also what's being donated to teams. On the front of the robot, though, we're going to use, you can get just conversion plates in order to change the X2Is back into a standard X2. Now, with the X2, the motors are sticking up, but we have less room here. We can run our interior post or frame member right back against the side of the Swerve module. That's going to save us about 2 inches on each side of the robot, or 4 inches total. And that's going to give us room for 2 inches more in length on the robot. We're still, I think, going to have to cut the hopper down, but it's going to be something like 1/2 inch total that we have to cut off of it. So that's going to solve our problem there. If you are not one of the First in Michigan teams or one of the teams that is getting a donated Swerve module setup, and you're looking to kind of follow along with this, you can do all 4 Swerve X2s, and that's fine. The motor sticking up in the back will not be in the way. Or you could get, a set of 2 and 2, or you can get a set of 4 and get the conversion plates like we're doing. It is also possible that other brand Swerve modules will also work for this, but you're going to have to figure out how to package them and make them fit on the rest of the frame that we have. So that's going to be our goal. We're going to start out with reassembling 2 of the Swerve X2Is, the inverted versions. Because we made a video for that and nothing has changed in the assembly for those, we're going to jump to that video first. Remember, though, when you're going through that video, I might mention, hey, build 4 of these. Just build 2. We're only building 2. Then we're going to come back and we'll build 2 of the non-inverted ones. All right, we're going to get started with those X2Is. But before we do, we're going to give a special thanks to our sponsors, Argosy, First, Across the Road Electronics, West Coast Products, Aramco, and Team 302, Lake Orion High School, for hosting our studio. OK, first thing we're going to look for is the Swerve X2 hardware kit, and open that up. So this is going to have a lot of the bearings and bolts and various pieces that we're going to need to use. And the first thing we're looking for is there's this big ring. And this is actually going to be our bearing retaining ring. So we can go ahead and open that up and take this out. You do want to be a little careful with this. It's kind of thin metal, so you can bend it if you're not too careful. And we're also looking for, I guess I'll just open up the bolts here. So we have 2 different little compartments, but I'm just going to open both of them. And we're looking for the shortest button head bolts. So we've got a few different bolt head types, if you're not familiar with it. The ones that are sort of like cylinders, where the Allen wrench or the hex key would go inside in the middle, those are called socket heads. And then the ones that are sort of rounded over, those are our button heads. And those are the ones we're looking for. And there are a few different sizes. We want the shortest ones, and we're going to need 5 of them, 1 for each of the holes on this ring. So I'll take a second and organize my bolts here a little bit. So like that's it. And also note that this piece has a magnet in it, so it might grab some of the bolts and pull them away. All right, so I've got my 5 short ones there. Kind of a pile of these off to the side. All right, then we'll need the corner bottom mount plate. And this one, you'll kind of know it's the right one because on one side there'll be there's sort of a lip at the bottom of this hole that a bearing is going to go in, and then this piece is going to go on top to hold that bearing in place. And that bearing is in our cardboard box here. So we'll open that up as well. Okay, and on the bearing, there's a couple of small differences that you'll be able to see. So one side, if you look in, you can actually see the balls inside as they move around. The other side sort of has this bronze-colored shield. And we're going to go ahead and have that bronze-colored shield facing up when we line this up with the hole on our plate here. And the idea is we just want to push this in. If you're careful, sometimes you can get it to go without hitting it. But I think most of these I've had to tap a little bit. So when you're putting this in, what you want to look for is if it goes in evenly, it's going to go in the smoothest. So whichever side is sticking up the highest, that's sort of where I'm pushing with my thumbs to try to knock that side down. So it's kind of up on this side now. And by working around like that, we're able to kind of get it to drop all the way in. Now, if yours is tight and it's not going, it's sort of the same process. If a side is up high in the air, that's okay. But then that's the area you'll want to tap with the hammer. So whichever side is up high, you sort of work your way around hitting the high side with the hammer. Make sure you're not using a metal hammer. Use something soft, plastic. And your taps don't have to be super hard. Just little taps to get it moving. Okay, once that bearing is in, you want to make sure, you can kind of check on the other side, make sure it's down all the way and it's flat. If you sort of feel on the top surface here, the bearing is at or below the ridge around it. It's almost exactly even with that ridge. So if you feel any bumps of the bearing sticking up, you're going to have to tap it a couple more times. All right, then we're going to take our retaining ring and line that up. And basically, we're going to screw these bolts in everywhere they go. But we have one more problem that we have to worry about, and that is when we screw these bolts in, there's nothing that really holds them in. We'll tighten them in, and they're going to be tight, but then this thing is going to be driving around. It's going to be getting hit. There's going to be vibrations on the robot. These bolts will loosen up over time if we're not careful. So one of the things we want to use on all of the bolts that we're going to be putting in is some Loctite, or thread locker. And what this is, it's basically glue. You put a little drop on the bottom of the bolt. When you tighten it in, I think technically it works in an anaerobic environment. So when you tighten it in and there's no more oxygen, no more air there, then the glue will cure and that'll hold it in place. Now, for Loctite, there's a few different types. Make sure you get one that's blue or medium strength or removable. If you get a red one, that's permanent, and the only way to take that out is to hit it with fire, basically, to break it down, and we don't want to be doing that near the bearing. So I've got Loctite 243. I think 242 also works pretty well. And then generic brands or other brands of thread locker will work as long as you're getting the medium strength. And I think all the medium strength ones, for the most part, are blue. So we'll open this up. And I think these bolts are going to be the 1/8 hex key or Allen wrench. And the way it works is we're just going to put a tiny drop on the bottom of our bolt. And it doesn't take a lot. So I think a lot of times people will get too much on there, but that's it. Just little drop. If you put too much, you can wipe some of it off and try again. It's not the biggest deal if there's some extra going in the holes either. All right, so we'll get this one started on one of our holes here. Okay, and I'm gonna take this one down till it's just touching, but I can still move the retaining ring around. I'm not gonna tighten any of them down until we're sort of all of the bolts are started. So another drop of Loctite. I think I'll get them all started here. And we're going to be looking to add this drop of Loctite to pretty much every bolt we put on in this entire build. All right, get the last one started. And I like to kind of make it tight by using the long end in the bolt and the short end to turn with. And once they're all that tight, we're pretty close. Then I'll go in and put the short end in. And it's just one short tug. It's, I don't know, maybe a tenth of a turn. It's not even a quarter of a turn that it moves at this point. So just give it one tug just to make sure it's in all the way and tight. All right. And then kind of always want to be checking as we go through. So after this is in, right, just feel that inner bearing, make sure it's still, or the inner part of the bearing, and make sure it's still spinning nice and freely. All right, so this step is done. Next step, we're going to grab, this is the X2I base kit. So this has some plates that we're going to be able to mount stuff in. We've got some bearings here and then some standoffs. So I'm going to go ahead and open this up. Our next step is basically going to be to put most of the bearings where they're going to go and get those all set. So all these little stand-ups, we're going to get off to the side and hopefully not lose any of them. Open up the little bearing pouch too. And then there should be 2 plates in here. This is just saran wrap. All right. And so the 2 plates are, there's one that looks like this. This is going to be our motor mount. We're going to do that one kind of second here, so I'll set that off to the side. The first one we're looking for is, I don't know, we got kind of to a point here and 3 big circles. So this one, we're going to start adding bearings to. The key is we have to make sure we put it on the right side. So on one side, it's completely flat and there's nothing sticking up. On the other side, there's this one bump here that is sticking up a little bit off the bottom of the plate. That side should be facing up. That's the side we want to put the bearings in from. And we're going to be adding bearings to these 3 holes. Now, I think the 2 of the bearings were in the kit that we just opened, but the really little bearings aren't going to work for us. So there's also another bag here. This was in the hardware kit that we want to open up. And this will have the rest of the bearings that we need. OK, so one of the things we're looking for from this kit is we need sort of the biggest bearing. But there are going to be 3 of them that all have the same inside hole. The difference is on 2 of them, they're just completely smooth on the edge. The third one has what we call a flange. So this one has a little bump, a little lip here sticking out. And that's the one we need. So just like the other 2 that we found, they also have that lip or that flange. So we have those 3 flanged bearings that are going to go in. And it should be the only ones that fit. So like this one, too big, won't fit, or way too small. So you should be able to get the right ones by checking that. But if you measure the inside of this hole, it should be a little over ½ an inch. And we're going to go ahead and you can try to press these in by hand. These ones, I think, are a little tighter. But if you can get them started, that's also helpful. Okay, this big one looks like it's going. You can see I'm pushing on opposite sides. And it's sort of moving down a little bit every time. I usually prefer, if I can get it to go in by hand, I usually prefer to do that because anytime you're hitting it with the hammer, there is a chance, if you're not careful, of doing some damage to it. But these ones are just way too tight, so they're not going to go. So I'm going to get, this time I'm going to use the dead blow hammer here on one of them. And I actually will just tap the one that I put in to make sure it's all the way down. And then we'll go ahead and do one of the ones on the side. So I can see that this edge right here is sticking up the highest. Like if I look at it from the side, that's the highest point. So I'm going to go ahead and start by giving that edge a little bit of a tap. And then kind of the other edges. And I like to sort of basically, I'll tap it around in a circle. So I'm aiming for different points as I go. And you can usually get away with tapping it just in the middle once it's in and it's moved a bit. You can feel around the edge with your fingernail. If your fingernail can feel that there's a gap on the side, it's not all the way down. So this one's not all the way down. We got to keep going. So we'll tap it a few more times. And then again, check. Make sure you should feel no gap all the way around. That's how you'll know it's in, it's flat, and it's all the way seated. And I think it was good, but I felt compelled to tap it again. All right, so we have the other one. If you have a different kind of hammer, I'll go ahead and use my rubber plastic mallet here on this one. And it's the same thing. The side that looks the highest is the side I'm tapping. And now that it's sort of in and it's started, I'm just going to work my way around in a circle, giving it little taps. And we'll check. That feels pretty much all the way in. We'll give it one more just to be sure. All right, so those are now all the way in. I can feel all the way around them. There is no gap, and they're in, and they're nice and flat. OK, we'll set this one aside and grab the motor mount. We're going to go ahead and put our bearings into that next. On this, again, one side is completely flat. This time, instead of have something that pokes out, we have a little gap here that goes in. So these two holes have a little, like they have a little ridge here, a little shelf that things can sit on. And so we're going to end up pushing our bearings in right on top of that shelf. Now, the bearings that we're looking for, again, they're going to be flanged. So we're going to have that edge on the side. And again, they'll be the ones that fit inside the hole. There are some other ones that I think would fit inside the hole but don't have the flange. So we don't want to use those. Make sure you get the two with that extra flange sticking out on top. And this one, I think I've had pretty good luck being able to push it at least most of the way in by hand. But I don't think it's a bad idea to, once you think they're in all the way, to give them some extra hits. We want to make sure that the bearings are in and they're all the way seated and that they're not crooked. If they're in and they're a little bit crooked, that could cause problems for us later. And if you feel, once it's in all the way, it should feel just about flat, just about even with the surface of the plate here. All right, those feel pretty good. OK, so we're going to set this one off on the side now. And we're going to get yet another piece to put a bearing in. This is the Swerve X2. This is the 88 tooth. This is our rotation gear. So kind of like the wheel is going to get attached ultimately on the bottom here. And then we'll be able to use a gear on the outside of this to make the whole thing turn, which will make our wheel turn. So we'll be able to steer. All right, so if we flip this over, we're looking for the side that has this machined kind of rectangular opening. That's the side that we're going to put the bearing in. We are looking for our last flanged bearing. And again, it will just fit perfectly into that hole. Now, this one's a little harder to hit. Usually, let's see, this is the fifth one I've done, and they've all dropped in pretty nicely. If it is tight and you can't press it in by hand, you'll have to get like a piece of wood or a piece of plastic that fits in that area. Or you could use a socket that's the same size as the bearing that then you can use to tap it in. OK, and that's the last bearing that we're going to worry about for right now. Next, we're going to look for a couple different packages. We need the bevel gear shaft. On this kit, it's a 15 tooth. And there will be two gears that we can choose from because we have the X3 and X4 ratio options available to us. So one of them is a 16 tooth. This is WCP 0732, but it's a 16 tooth steel spur gear with a 3/8 hex bore. And the other option that we have here, it says 14 tooth steel spur gear, but it's a 16 tooth center distance, also with a 3/8 hex bore. So I'll go ahead and open up our bevel gear here. And I'm going to open the 16 tooth gear just to give you an idea. So this gear is eventually going to sit on here. So the idea is we're going to have another gear that drives this gear. This gear then will drive our bevel gear. Our bevel gear will drive another bevel gear, which makes the wheel spin. But what we need to know for right now is we have a fixed gear that's driving this one. And the smaller this gear is, the bigger our ratio is going to be. So the smaller this gear is, the faster everything is going to spin. So if we use the smaller 14-tooth gear, that we didn't take out of the package yet, that is going to make our overall robot speed faster. If we use the 16-tooth gear, it's going to be a little bit slower. So you can pick the one you want. There's actually a chart that we can show you that has all of the different gear ratio options available to you and sort of the estimated free speed of the robot. I'm going to build this one at the slowest speed that is available for the X3 gear set. And that's just because we're just going to be driving it around in the small room here, and I don't need a ton of speed. The actual speed that you should use for your robot is going to be based on the game setup. So you have to decide, do you have to drive long distances often? If so, you might want to try for a higher gear ratio, a higher free speed. If you're going to be working in one area, but you got to be able to move back and forth quickly in that smaller space, a smaller gear ratio will give you a faster acceleration and is a little bit easier on the battery, so that might be a better choice. The other thing to keep in mind is we're just doing a chassis with the Swerve drive modules in the corners, which means our robot, this robot, when it's finished, is going to be very light compared to an entire FRC robot that you're using for competition. As the robot gets heavier, acceleration will go down a little bit because you got to move more mass, and the battery draw will also increase because, again, you're moving more mass. So that's just some things to think about when you choose your final ratio. Okay, so we can't actually put the gear on yet because we got to put some stuff on in between. Let me move these other bags out of the way. And we're going to grab that rotation gear that we were working with before. Remember, there's the big kind of rectangular cutout side, and then the other side, I don't know, just has kind of a lightning pattern here. So on the side where the rectangular cutout is, we're going to take that bevel gear and drop it through the bearing. Then we're going to flip it over. And now we can go ahead and put that gear on. So again, I'm using 16s, but you can use the 14 with the 16-tooth spacing. That's the other thing about those gears is the 14 and 16 tooths have the same pitch diameter, which means they will both mesh together with the gear that's going to drive them here. And so you can just swap them out with no penalty. You don't have to move things around. Everything stays in the same holes. So that's a really cool thing that we can do. Now, in order to keep this whole thing from falling apart, we're going to end up putting a retaining clip on here. And if you look at the top of this bevel gear shaft on the side, you can see there is a tiny little groove that we can use to drop something inside of there. So when this gear goes on, it'll go just past that groove, and then in that groove, we're going to look for our retaining clip to be able to hold it all together. Okay, so we'll get our retaining ring. And before we go working with the retaining ring, let me warn you, when you're doing this and you're opening it up, it gets a lot of kind of spring energy stored in it, so it's very easy for these things to go flying. So we're going to do a few things to try to make sure it stays managed, but be very careful with these. All right, you're also going to need the retaining ring pliers. And the way the retaining ring works is there are two tiny holes on it, and the retaining ring pliers have these two pins on the end. And the idea is, if you put the pins in the holes, let me move things around so I can actually see what I'm doing here. All right, then, and I'm not going to let go of the retaining ring when I do this, but then when you squeeze on this, you can see I can force that retaining ring open more than it is. So I'm going to kind of line that up on top of our bevel gear shaft here, and I'm going to keep my finger on the retaining ring when I squeeze it open. And what you'll see is it'll just sort of fall right in to that groove. You'll feel it in the groove. Then you can let go and release. And now you'll see that that gear can't come off anymore because that retaining ring is holding it in place. Now, taking this off, if you have to go back in and work on stuff and change things, is almost impossible to do without the retaining ring pliers. But I will show you a way that you can kind of put it on without the retaining ring pliers if you don't have them and you're in a hurry. So let me see if I can get this. Oh, you'll also note, of course, too, that right now there's nothing holding our bevel gear into our rotation gear here. We're going to fix that in the next step. So if yours falls out, don't worry about it. All right. Okay, so we'll take that off. If you don't have the retaining ring pliers, what you can try to do is you can sort of feel it drop down into the groove on one side. And if you can get the one side into the groove by pushing down on it like this, you can see I'm sort of half in. So it's in on this side, but the rest of it's not. Then you can usually push over on the rest of the clip to get it to drop in. So I'm back in and we are retained. It's definitely easier with the pliers, so get yourself a pair of pliers if you don't have them. And for sure, if you ever have to do maintenance on these things, if you're ever going to need to take them apart and put them back together, you're going to want those pliers for that anyway. But if you're in a hurry and you need to get this thing assembled today, you can get these sort of snapped on. All right, let's move on to our next step now. Make sure that bearing is all the way back into the gear here, our rotation gear. And we are going to look for, these are the wheel fork kit. So I'm going to open those up. And I think, oh, we got some more saran wrap on these to keep them nice. Okay, so there are two different forks in here. They're almost the same, but small difference. If you look from the side, one of them, the inside has this hole cut out completely, and one side, it's not. There's still some pieces there. So the first one we're going to need is the one where the hole is missing completely. You'll also notice on this one that on the side here, down in this area, there is room to drop a bearing in. There's that little hole for a bearing. So that's the next thing we're going to do, is we're going to end up dropping a bearing in there. There are 3 bearings that are very close and actually would all probably fit in that spot. So we have 3 different bearings. Now, 2 of them are too big, and we're going to check it by putting it on the end of the bevel gear, right next to the bevel gear on that shaft. If it's big and loose, that's not the one we want. All right, so the smallest opening of these bearings is the one we're looking for, and that should sit nicely on that little post on the top here, and end up about flat with the edge of that. So that's the bearing we need. We're going to press that into the hole on this fork. Okay, so if you line that bearing up with the hole on that fork, just like the other gears here, if you can push on the high side, you can sometimes get this to go in just by hand. And mine is going. It's a little tight, but it is going. Okay, and we'll make sure that's down and flat with the surface here. Now, if you can't push that in by hand, obviously the hammer's not going to fit inside there. So once again, you would need to get, maybe a piece of wood, maybe a block of plastic, or if you have some long sockets, you might be able to get a socket that's the size of the bearing that you can put on top of it to hit it. But you have to find something to go in between there to hit it in. I was able to press most of these in by hand, though. All right, this piece now is going to go down on top of our bevel gear here. And there's a couple different orientations. It could face this way, or we could put it on facing this way. And what we're kind of going to be looking for here is the outside is sort of curved, and it should line up with the curve on the rotation gear here. So if those curves line up, that's the right way. If you turn it around, that's the wrong way. Also, sort of the smooth curve area is facing out. There's this hex pocket cut out here for a bolt or a washer that we're going to use later. That should be facing towards the outside. And once that's lined up, we're going to be looking for our 4 longest. So we need these socket head cap screws. Okay, so these 4 bolts, I think they're 1.5 inches long, but let me measure it to double check so I don't lead you astray here. And let's see, so that one is, yep, 1.5 inches. All right, so we've got our 4 1.5-inch bolts ready to go. Before we put the forks on, though, it actually is going to get attached together with this first piece that we made, our kind of corner support with the big bearing in it. Now, what we want to do is we want to hold this so that the bolts that we use to retain the bearing are facing down. Then you can take our rotation gear here with the bevel gear that was assembled into it, and the bevel gear should be facing down, and this is going to drop into the bearing. And if your bevel gear falls out, just make sure you put it back in. I think it has to be in before it goes together here. Otherwise, it will be blocked a little bit from falling out. So now that can't fall all the way out. Okay, so this is on top, and it should spin nice and freely. So you definitely want to feel that kind of before we move on to the next step. Okay, now we're going to flip this over. Don't let it fall apart. And now we're going to be able to attach our forks onto our two sides here. So the first side is we have the bevel gear. We have the fork that had the bearing into it. And really, it's going to be hard to put this on the wrong way, because if I try to have this facing the wrong way, the forks are going to hit the sides of our support and our machined rotation gear here. So you want the curved edge of this to be facing out when you go in, and it's going to rest nicely against the bearing once it's in the right spot. So once you have that in, go ahead and take 2 bolts. And because these are socket heads, not button heads, we're going to move up 1 size for our hex key. This is now 5/32. And I'm not going to add Loctite yet. I'm going to go ahead and tighten these down, but then I'm going to loosen them up just a little bit. I find that when we go to put the wheel in place, having these be loose is pretty helpful. So we're going to leave them just a little bit loose. So I kind of like tightened it till it touched and then backed off a little bit. So there's just a little bit of a rattle in that piece. Not enough for any of the things to really move, but that'll give us some play when we go to drop the wheel in between here. And then once the wheel is dropped in, we are going to take these bolts out one at a time, add Loctite, and put them back in. All right, then on the other side, so we did one side here. On the other side now, we've got 2 more tapped holes here ready to go. We're going to take our other fork piece. This one doesn't have the hole in the middle, but the side that is the cutout will be facing in towards the other fork. And again, the rounded side facing out, and that should nestle right in there perfectly. And we'll drop in 2 more of those 5/32 by 1.5 inch long bolts. And same thing on this side. We're not going to Loctite it yet. We're just going to get them snugged, but then loosened up a little bit so we have some play. So just back it off just a little bit, and you can see that one still rattles. All right, so this section is now ready to go. Next is to take, basically we're going to have another post coming up from this. More gears are going to go in, so let's find those gears. We're looking for the double gear 54-tooth/40 tooth steel. This is 1715 part number. And it's basically going to be 2 gears stuck together. One of them is that 54 tooth, and then the smaller one is the 40 tooth. And this is going to ultimately go on here, and those gears are going to mesh together with the that 16 tooth that we put on a while ago. But a few things we have to do. First thing is this gear has spots for bearings. So we're looking for 2 more bearings. These are going to be the skinny looking bearings. Biggest kind of hole in the middle, but they're also very thin on the sides. And they're also not as tall as these ones. So our really big ones we don't want, and our really tiny ones we don't want. These are kind of the in the middle size. And they should go right into this bearing on either side. And again, I'm just going to sort of wiggle it in whatever side's high. That one went in fine. If you have to tap it with the mallet, go ahead. Same thing on the other side here. That one went in nice and easily. All right, so we have our gears on there. Kind of set this down for a second. Now on this piece, we need the shaft that those gears are going to attach to. So we are looking for, it looks almost like a bolt. It's got sort of like a hex shape on one side. And the other side has this magnet in it. So you'll know it's the right piece if you've got the one with the magnet that can stick to stuff. All right, and it sort of has this funny shape on it. It's like 4 sides of a hex and then a round section. And on our rotation gear here, we have 4 sides of a hex and then a round section as well. So this is going to drop into that when everything is lined up, and it should fit more or less perfectly. Also, I will mention the magnet on top of here. We're going to use that magnet with a Cancoder, a sensor that can basically detect the spinning magnetic field from this. That's going to be our rotation sensor. All right, on the bottom of this, there is a tapped hole. That hole is for our biggest bolt. So this is actually not a number 10 bolt. This is a bigger one. This is a 1/4 inch bolt. So you find your 1/4 inch by, that looks like half an inch to me, maybe, yep, half an inch. So this is our 1/4 inch bolt by half an inch long. And again, we'll drop this back in. That bolt then is going to come from the other side. So I'm going to hold this in with one hand and flip this over. And this bolt is going to drop into this side and be good to go. But of course, before we do that, we definitely need to Loctite this one. So let me get the Loctite here, get ourselves a nice little drop of it. Okay, and then I'll go ahead and drop that into here. And this, because it's a 1/4 inch bolt, we need to move up yet again to a 3/16 Allen wrench or hex key. And we're going to go ahead and screw that in all the way. Okay, and then when that's tight, I am going to flip it over to the short side and try to give it one more little tug. In order to do this, you're going to probably want to hold on to one of the forks or both of the forks so you can have something to pull against, because otherwise it's just going to rotate the whole mechanism. All right, that's in and tight. Next step, we're going to take our gear, and the smaller gear goes facing down, and we're going to drop that onto that shaft that we just put in. Now, it's happened to me a decent amount that this top bearing pops out because of that magnet. So if you can push it in and it stays, that's great. But it's pretty easy for the magnet to kind of catch that. And I've actually had the magnet catch it and have it pop out pretty quickly like that. So there is another piece that's going to go on top of here. And it is in this little baggie, which, you know, we need both of these pieces next. So we'll take both of them out. But there's this little plastic ring that's supposed to sit on here. That's going to be a spacer. But as you saw, when the bearing popped up, it sent it flying. So we have one more kind of area to prep and attach before we're going to end up putting the piece that holds this in. So I'm going to not put, either I'm going to have the bearing be out and put that on, or safer still, I'm just going to have that spacer be on the side here so it doesn't pop out and I don't lose it. So slide those off to the side for a second. All right, next is this shaft here, and it is hollow. And it sort of, again, looks like a bolt because it has that flanged section. It has one side that's raised up a little bit. This is ultimately going to sit in that raised bump that we were worried about to make sure we got the right side of this plate before. This is going to sit in here, and another gear stack is going to go in, and that gear stack will then be able to move the rotation gear. So we need another baggie here. This is 1710, or the double gear, rotation double gear. So this is a 22 tooth and a 16 tooth gear that we're going to be using. And again, just like the big double gear that we just put in, there's room on both sides of this for a bearing. And these are going to be our tiny bearings that are left. You'll know that they're the right bearing because they will fit nicely onto that shaft that we just pulled out. All right, so we're going to press these in, one on the big gear side and one on the small gear side here. Okay, and those go in pretty easily. Okay, and then we can sort of check. I think we go through the big gear side, but you'll know it's right because if we take this over and drop it into that hole, we need the gears to mesh together down here. So we can see the bottom gear of this stack is meshing together with our rotation gear, so they can cause each other to turn. So we know that's the direction that that's going to go in. All right, and actually we can go ahead and put that in there now because that's, you know, where we want it to be. So now we're going to take, there is this piece that we used at the kind of the very beginning, push those bearings in. This is going to sit on top of all of this. So I'm not going to put the extra little ring in quite yet, but just so we can get everything situated, oriented. On this piece, if you remember, there is the big bearing in the middle. That big bearing is going to go onto that middle shaft. The other thing we're looking for is that raised bump section again. So that raised bump section is going to sit on top of our other shaft. So it's going to sit something like this. Okay, but we've got to have that spacer and that gear in. So now that I know where it's going to go, and I've practiced it once, just because this gear is going to maybe try to pop out on me, I don't want to have to be thinking about where stuff goes while putting it together. So I'm going to put that spacer on. I'm going to kind of keep my finger there just so nothing goes flying. And then I'm going to get that lined up. So again, that center bearing lined up on that shaft. Rotate it until the other one is coming down on the other shaft. And what you might have happen, which is what happened to me here, is that gear kind of popped out again. So I'm here trying to wiggle it to get it to go back in so it'll sit all the way down. Okay, so let's see if I can get this to move. Nope, let me bring it out and reset. So, whoop. All right, put the gears back, put this piece back in where it goes. Okay, and it's okay, if stuff falls apart, not a big deal. So I gotta get that gear to go down. And now we'll try one more time. Hopefully it doesn't pop up on me. So we're going down there, and nope, popped out again. Okay, as long as it stays in like a little bit, we should be okay. This time I'll try to keep my finger on for a little bit longer here as we slide in. Okay, there we go. All right, and so what we're looking for here is, I gotta get the other one lined up too. So what we're looking for here is this shaft should end up coming up basically flat with the top of the bearing here. And then on the other one, make sure that the axle's in so that this gear is trapped on the top and the bottom. All right, then we're gonna go ahead and attach a couple things to keep it from coming apart on us. So these long bolts that we have here, there are actually two different lengths. Let's see if we can find one of the different ones. There are 2.5 inch long ones and 2.25 inch long ones. So there we go. So what we want is one of the shorter ones, 2.25. And that is going to go all the way through the hole in the middle of this gear down here. Of course, we do want to add some Loctite to it. You can, I've seen people who like doing it either way. You could add the Loctite to the bottom of the hole here. And that works nicely. Usually some of it ends up kind of leaking out from the bottom of the hole afterwards. So you could wipe that off. Or you can just continue putting a little bit on sort of the bottom of the threads. And the downside to this is some of that will rub off as we drop it through the long hole. But it's going to work just fine. So we'll drop that through, get that started. We're back to our 1/8 hex key here. Okay, and I'm going to leave this one just a little bit loose again. So I have some play on this. We're going to need that to be able to line up our motor plate, which we're going to do next. The other side of this plate, so if we jump all the way to the opposite side of the plate, this corner hole here is another spot where we can put a support here to hold it together. And if you are going to be using what is the bottom support plate, so eventually there is another plate that can get added down here. If you're going to be using the bottom support plate like this, which we are and which will be included in the link that we are including with this video, you're going to use a 2.5 inch long bolt. If you're not using the bottom support plate, if you're attaching stuff together differently, then you're going to want to use another 2.25 long bolt. The idea is this one's going to stick out a little bit, but we're going to use the bit that's sticking out to attach to the other piece. And we also are going to need to find, there is this one more baggie here. It has one round standoff and then a bunch of sort of like washers with plus-ish shaped round holes in them. We need the standoff from inside here. So we're going to open that up. I guess we'll pour everything out. So this standoff should fit perfectly in between here. All right, and then we'll go ahead and add a little bit of Loctite to the bolt. And I'm up a little bit from the bottom because the bottom is going to end up sticking out. So we'll drop that all the way through there. And then screw this in. And you'll be able to see as I screw it in, it's going to start poking out of the bottom, which is what we want. We're going to end up screwing something else onto that. Okay, same thing with this one though. I can't have it too tight yet. We need some play to be able to align and attach other stuff together. All right, so that looks good. If you're going to be sitting on this, if you're going to leave this for like a long period of time, before you complete the rest of the assembly, then you probably don't want to add the Loctite now. You'll probably want to go back and add the Loctite as you assemble everything together permanently. So you could do like we did with the forks and put the bolt in, and then when it's time to Loctite it, you can take it all the way out and Loctite it and put it back together. So if like you leave it overnight, the Loctite's going to cure. But if we build the next section relatively quickly, we'll be able to put it in, tighten it, and then the Loctite will not have fully cured yet. So let's set this off to the side. We're going to grab our motor mount plate that we had here from before. Okay, and we're going to get our motors. So we are using Kraken X60 motors everywhere on this build. So for both the power and the steering. I think there's some other motors coming out that are like similar, but a little bit smaller, a little bit maybe less power, that you might want to use for your steering motor instead. So that is an option, but you know, it's pretty simple to just get all of the same motor. You need less spares, everything goes together nicely, and you kind of don't have to worry about stuff. Now, these motors are going to go into the other empty hole here, and there's actually a raised, you know, boss on this motor that should fit and help guide it right into that hole in the middle. And when you put it in, it should still be able to turn a little bit. This motor can be aligned however you want. We have kind of all of these mounting holes that can be used to bolt it on. We're going to end up using kind of these two diagonal ones here, or the ones opposite each other. You definitely want to get bolt holes as far apart as you can when you're mounting it, but you can adjust the angle of this, and that will change where the wires end up poking out. So if you know what orientation you want that to be for your specific robot, just know that you can do that differently than we're going to be doing it here. But the easiest way to sort of have these pointing towards the inside of your robot is to make the flat section on the motor match the flat section on the back of this mount. And I'm going to go ahead and put both of the motors in here. That's nice because then they can kind of support each other. And we are looking now for, let me see, I think these are 1/2 inch long. Yep, so these are the, again, button head 1032 button heads, 1/2 inch long. And they're going to go here and on the opposite side here. But again, everything is going to get Loctited. So let's add a drop of Loctite there. And you might have to look down to make sure the holes line up if it doesn't go right away. So all of these things, like the bolts when they go in, they should go in nicely. You shouldn't have to force anything. So if it feels tight, you know, back it out, check, make sure you're not cross-threading the hole, make sure your holes are lined up. But you shouldn't really have to fight with it. So if you're fighting with it, that means something is not quite right. All right, so we'll get those in. Once I have both of these in and long side tight, I'll do the short side with one extra tug, just to make sure they're in all the way. Then we'll do the other side, so 2 more of those bolts. A little bit of Loctite. Line it up. You can also kind of feel too, when you rotate it, you'll feel the bolt sort of drop in when the holes line up, so that helps too. Another bit of Loctite on there. And make sure those are nice and tight. All right, then we need something to go on these motor shafts. So this is the shape of these. It sort of looks like a gear almost. This is called spline X. S is the shape, but this is a spline shaft. And what we're going to do is we are going to attach gears onto these. And the gears that we're looking for now are, there are 4 bags that we get to choose from here. And so there are 2 of them that's a 10-tooth steel spur gear, 12-tooth center distance, spline XS board. There's also an 11, and there is a 12. Okay, so the left motor, if the flat side is facing towards you, on your left, or you know, if I turn around so we're the same, on the left, this is the steering motor. Okay, and the other one is the the propulsion motor. This is the motor that's going to actually spin the wheel and make us move. The left motor, the steering motor, is going to get a 10-tooth, 12-tooth center distance gear dropped on it. So we're going to do one of those on this side. Now the other side, the right side, this is where you get to choose your gear ratio again. You could do a 10-tooth gear, an 11-tooth gear, or a 12-tooth gear. And again, there's that chart which shows you what sort of the free speed would be for your robot based on what you pick. Remember, I picked the 16-tooth before. So you can see on the chart, you choose 16 if it's a X3 ratio. If you want to do the X4 ratio, that's a 14-tooth gear for that first step. And then the second step, you have 10, 11, or 12-tooth gear choices. And you can see the accompanying speeds that goes along with that. So again, for mine, I don't need to go fast. We're in a small area. I'm going to stick with the slowest speed. So it's sort of the easiest for me to deal with here. So I'm going to put another 10, 12 on the right side. But if you want yours to go faster, a little bit faster, use the 11. If you want it to go a lot faster, use the 12. All right, so you will have, now that we're done putting these on, you will have 3 of these gears, one that we didn't use in the 14 or 16 choice, and the 2 that we didn't use here in the 10, 11, or 12 choice. Those will be extra. Those don't go anywhere. Don't worry about that when you finish. But save those, because if you drive your robot around and you decide, oh, it's a little bit too fast or it's a little bit too slow, you can always go back and make swaps if you disassemble stuff. All right, back to assembly here. We need these gears to not be able to move up and down like this. So those spacers from the previous step that have sort of that plus shape, I don't know, it's like a hole but with some extra cutouts in it. We're going to drop 2 of those on each side. And it should end up then being basically flat with the top of our output shaft on the motors. Okay, then we're going to grab, there are these 2, they've got like a big flanged washer head attached to them, bolts. And these are going to go on here to hold those spacers in place. And then if the spacers can't move, the gear can't move. And you'll notice these do have a little blue patch on them. So there is already Loctite on these. You probably don't need to add another drop of your own Loctite, but you can, and it's not going to hurt anything. Okay, so you'll get that started, and we'll start screwing that in. That, I think, is still the 1/8 hex key. Now with this, these are very shallow, so make sure your hex key is in all the way when you turn. You don't want to strip these out. The other thing, too, is if you just turn, the motor shaft is going to spin. So you got to hold on to the motor shaft, and at some point, you might not be able to hold on anymore. If that's the case, you can try a few different things. Just grabbing like a rag or a shop towel like this gives you a little bit like the ability to hold on tighter because you're not pinching down on the sharp stuff. So that might help you get it to where it's tight. At some point, it's going to try to rotate on you no matter what because it's all the way in, it's all the way tight. That's OK. As long as you kind of hold it as tight as you can and torque that down, and there's not much of a gap here, then you're probably in good shape. Now, if you can't get it to tighten, you can grab on to this output gear, but we have to be very careful not to damage it. So if I were not able to hold this and it just kept spinning and I couldn't get this to go tight, I would grab a pair of pliers. I like sort of the kind of the flatter side or the ones that have the gap in the middle, so it's sort of like the shape that we're looking for. But I'm not going to just go ahead and grab onto this directly because that is going to damage the gear teeth. So if I wrap it with something like a cloth or a thing, a paper towel, something like that, then you can squeeze into that and there's some protection there. But I'm not going to squeeze super hard on this. I'm just going to squeeze enough that I'm able to sort of tighten this down. Okay, and then after you're done with that, you can take this off. You should definitely inspect the gear teeth here. Make sure you didn't do any damage to them. So mine still look like in very good shape. Again, it shouldn't take a ton. And because there's Loctite on this bolt, when we tighten it down, it's going to sort of hold where it stops. So getting it super tight so that it helps hold it from loosening up is not as important because the Loctite will do that job. Also, there's no real forces on this gear that is going to make it want to pop off. So the other gear is going to make it want to spin, but nothing is pushing up on this. So we don't need this to be super tight to hold it all together. We just need it to be there. And the Loctite's going to do a lot of that job. All right, other side, we can do the same thing. Again, add an extra dot of Loctite if you want. And we'll get that screwed in on the other side as well. And we'll hold it with the towel because it's less pokey. And for me, I think that's good enough. That's tight enough. I can kind of compare. Just in case you're getting really worried about this, these are tight as far as they're going to go. If I wiggle the spacers here up and down or left and right, there is just a tiny bit of rattle there. So don't expect the spacers to get nice and tight. I can spin them. They'll spin around in place and stuff like that. And that's OK. That is tight enough. All right, next up, we are looking for more packages. These are the 38-tooth pocketed steel spur gear, 3/8 round, quarter round. So 1723 is the part number. We're going to open these up. And they are going to go into the bearings that we pressed in earlier. And you'll know which direction it goes because one side doesn't fit in the bearing. The other side is small enough that it will drop right down into the bearing and it will mesh together with the pinion gear that we put on the motor. So we're going to do that on both sides. These gears are the same, so it doesn't matter which one goes on which side. And we can drop that in. There we go. All right, now, kind of the tricky step. We got to bring all of these together with our previous section. And let's get oriented so we're looking at it the same way. There is the direction that the corners are kind of pointing. This is going to come in on the diagonal of those two corners. All right, so this is the outside. This corner here, this is the extreme outside corner of our robot. And so the motors are going to end up on the inside of the robot coming in. Now the next thing we can look for is these gears that we put in, that we just put in. Those little shafts are going to fit into the two empty bearings that we have left on this plate. The other things we're going to look for is this gear that's right here that we put in, this gear stack. The top gear is going to mesh together with our steering motor gear. So it'll be steering motor and then our intermittent gear, or our intermediate gear here, and then that one. And the other gear on the other side, which is our power motor, is going to interface with the big gear in the middle here. All right, so the idea is we're going to just slide this together, try to get those bearings lined up. And once those bearings are kind of lined up, the next trick is wiggling the gears so that the teeth line up. Because if the teeth don't line up, it's going to hit and it won't go in. So if we can get the teeth to kind of mesh together here, then we should hopefully be able to lift this motor up into those gears. Okay. And you might have some luck too. Once you get it going, you might have some luck sort of flipping the thing upside down to help. So gravity helps you instead of, you have to fight against it. And I'm kind of reaching inside and squeezing at the bearing to try to get it to move. There we go. That one dropped in all the way. And then this side, same thing. I'm going to pull around that bearing and see if we can get it to go. There we go. And once again, you're going to work on this until it's nice and flat here on the side. Right? And if that doesn't go in for you, if you have to, you can unbolt the earlier bolts and put this section on the motor first. I find it's a little harder with the motors attached to this center section to deal with that bearing that was popping out on me. But it could definitely work that way as well. All right, so now that these are together, we're going to look to add standoffs and bolts to hold the motor to the top section and the motor to the top section and the bottom section in a different place. So first, on the flat side here, on the inside of the robot, there are 3 holes across the top. We're not going to do anything in the middle hole, but the outside 2 line up with tapped holes on the bottom. So we can do the same standoff thing like we did on this corner here. And you can tell which standoff it is by basically just testing a standoff height. It should fit. So it looks like it's the short ones. We have kind of a whole section here of shorter and longer ones. We need the shortest one to go there. And then bolts we are looking for, let's see, there they are. These are some more still button heads, okay, and they're still 1032s. And these ones I think are 1 inch long. Yep, 1 inch long. Okay, so these, basically the idea is we're going to go bolt with the spacer lined up. The bolt will go through the spacer and then line up on the bottom plate to screw in. But we need Loctite, so let's do the drop of Loctite on here first. Okay, and line the spacer up, drop the bolt through. And then we get that started. Again, I'm going to get it close, snugged, but not super tight yet. And the idea now is that we want, as I Loctite the other bolt for the other side, we want to make sure all of the bolts can get started before we tighten anything down. Because when we tighten stuff down, that has a chance of holding it a little bit crooked to where things maybe don't line up anymore. All right, so we'll line up the second spacer, screw that one in. Good. All right, and now I'm going to rotate this a little bit. If you basically start where that bolt we just did here, if you go towards the motor along that edge, the next hole you end up with out here is the next one we're going to do. And you can tell it's the right hole too, because if you look below it, it lines up with another hole here on the motor plate. And then if you look below that, there's actually one more hole on our bottom plate that also lines up. So for this, we're looking for 2 1/4 inch bolts, which are the shorter ones from our long section. So these are 1032 2 1/4 inch long button heads. You can test it by dropping it in. That will reach all the way down, and it'll stick up just a tiny bit, and that's how much we're going to be able to screw in. Now this one's a little bit tricky too, because we need not 1 spacer, but 2 spacers. So we're going to have one of our taller spacers here on the bottom, one of the shorter spacers here on the top, and we've got to drop the bolt all the way through everything. But of course with some Loctite first. If you can't get the spacer to go in, then what you need to do is loosen up some of these other bolts to make sure that we haven't snugged everything down too far. But it should go pretty easily as long as you didn't really torque them down. All right, we'll get our Loctite on here. And line up the first spacer, line up the second spacer. There we go. Screw that one in. And then I'm going to rotate it around. We're doing the same thing on the other side. So the flat side, the other bolt we did, basically if you follow the outside edge, the next hole you get to, that's the hole we're going to work on. So we'll do that Loctite. And again, small spacer first. And then the big spacer on the bottom. And then we can screw that one in. Okay, now that they're all sort of snug, they're all in the right place. Those are all of our bolts. I'm going to go ahead and tighten all 6 of them. So we can start with the one we just put in. And then I'll jump to the other side for that one. Okay, and then we can do the 2 on the short side here on the flat side that we did. And then don't forget to go back and do the one that went through the gears in an earlier step. And the one through the spacer on the back of our plate here that we did on an earlier step. And again, if you needed to, if you had this sitting around for a while and you didn't Loctite these 2, make sure you go back and add Loctite for those 2 as you put it together here. Okay, the last thing that we can put on the top of this module is our Cancoder. You can do this now. You could skip this and do it later after the rest of the assembly is done and you know which direction you want your wires to run. But I'm going to grab a Cancoder box and we'll open that up. And so the Cancoder is basically, it's an encoder. Encoders measure basically how many times things rotated or what position they're in. So that shaft has a little metal magnet on the top of it from before. And that magnet, I think it's polarized not so that this is north and the bottom is south. It's split on the top. So we can see there's like, it's part north and part south. So when it spins, we'll have a changing magnetic field and we can use this encoder or this Cancoder the little chip here, when that lines up really close to the magnet, we'll be able to detect that motion. So we can use that to read basically how far this is rotated or how many times it's rotated. We're going to then use that to help align our wheels, to steer our wheels. So we'll know like, oh, point forward, that's like go back to position 0. All right, so inside of this box, we have the actual Cancoder itself and some wires attached. There is also another magnet, which you can actually see. It attaches, but if I try to turn it 180 degrees, it will not stick anymore. Now the poles are opposite and it's pushing it off to the side. So we can see the kind of the magnetic field that way. We also need this case. So there's this plastic top part of the case. There is also a bottom part of the case that we don't need. And there are 3 screws in here, 2 short ones and 1 long one. We just need the 1 long screw. And that's everything we need from this box. We then need our encoder mount, our Cancoder mount. So that is a little 3D printed piece. It's got like a rectangular hole in the bottom, and there's a shape of a cutout in it, which like you'll see fits the plastic housing here of the Cancoder pretty much perfectly. So that's how that's going to go together. Now this Cancoder is going to drop into the spot here first. You kind of want to work the wires so that they're going to go back in this direction. We don't want them to go up because when this case comes on top, you can see the hole on the back for the wires to pass through. So we need to make sure the wires are sort of bent in a way that they're going to fit inside of there. Okay? And what we need to do is basically line this up in the middle as best you can. Bring that plastic case on top. And then there's space for 1 screw here to go down the middle. And you're going to need a little Phillips screwdriver for that. So let me grab one. Whoop. Okay, so we get a Phillips screwdriver and get everything placed back together. We're going to be basically cutting threads into the 3D printed part. So when you go to screw this in, if it just spins in place, that's kind of normal. What you need to do is push down a little bit to get it to bite and dig into the 3D printed plastic. So what I'm going to do here is just push down a little bit as I turn. And now that it's biting, it should keep screwing in nicely. If you still don't get it to go, you might want to check on the bottom. You can sort of, if you're very careful, look through and see in that hole that things are lined up. All right, but I think mine is going here. So we'll keep screwing that in. And be careful as you tighten this. This is just a plastic housing. There's nothing holding it, supporting it in the middle. So if you keep tightening this, you will crack the housing. You will break it. So once it sort of feels like it's not moving anywhere, that is probably good enough and you can stop. And if we look at the bottom, then you will see that sensor or that chip is there lined up in the open hole. And that then will get mounted onto here on top of that magnetic shaft that's going to be spinning. Now you can attach it this way, this way, this way, or this way. The only difference is the direction the wires are going. So if you know how you want to wire your robot, or you don't know how you want to wire your robot and you want to wait to figure it out later, that's fine. This doesn't have to be attached right now. Nothing else is going to be attaching to it. So it's not, in the way of anything else getting done. But for this robot, I think the easiest is, because the flat side is towards the center of the robot, I think an easy way to route these wires is down and then down this edge here. And actually there will be another spacer that's here that you can use to actually zip tie those two. So this seems like a good wire path for me. So that's the direction I'm going to attach these. We're looking for 2 more of those still button head 1032s. These are, say, 1/2 inch long. Yep, 1/2 inch long. And with these, you still want to probably Loctite it. These are probably the least important ones to get Loctited. But again, once you bolt it on, there's no reason that you're ever going to have to take it off. So you might as well have it locked in place so it is not moving on you. These are just easy to access, and they're not holding together something that's very heavy or is going to be seeing a lot of forces. So I'm going to line that up, get this one started. I'm not going to tighten that one all the way, so I still have movement on the other side. Loctite the other one. Okay, and here you just got to sort of move the wires gently out of the way. With wires, you just always want to be as careful as you can because they're just soldered into the circuit board inside here. So if we're pulling on them or doing a lot of crazy stuff, we can damage them. Now this, again, we're tightening into just the 3D printed stuff. So I'm going to tighten it with the short side, and that's it. I'm not going to put it in on the other side and do an extra tug. I'm going to make it sort of as tight as I can this way. Well, not even as tight as I can, but decently tight this way. You can feel it too. It should not be moving around, and that Loctite is going to help keep it from backing out. So we got those wires. All right, top is set. Next thing we're going to do is we're going to look at the bottom. We need to assemble our wheel and put our wheel in here. So we need a few different pieces, but first we're going to start with our wheel, and we've got tread that's going to go on, and we're going to need our bevel gear that's going to also go on the wheel. Now there are a few different wheel options that you can choose from. We are using, and the linked kit will be using, the aluminum hubbed wheel, and we just bought the treads as well from West Coast Products. These treads, you can buy the material, just this belting material, and you can cut it out yourself. On the assembly instructions for this on West Coast Products website, actually, they have a drawing that tells you exactly what size to cut this to and how to drill it. That said, it's pretty easy to just get the one that's already done for you, and you have space to, or the holes are really nicely drilled out. A lot of the times when my team was making these by hand, the holes that you would drill through sometimes are not quite nice enough, and getting the bolt to go through afterwards is hard because this is sort of like a rubber material. So you'll drill, but then the hole will close back up on you a little bit. So on this, they did a nice job of kind of opening up the hole on the backside. Anyway, if you want to try to do it a little bit cheaper, but you've got the manpower and you've got the time, go ahead and buy your own material, make your own. But if you just want the easiest way to get this put together, then you can go ahead and get the tread that they provide that fits perfectly on their wheel. All right, let's open up our wheel as well here. And we got bolts that we're going to want to get to as well. All right, we'll keep those bolts all in a pile here. Okay, so we can assemble this in a few different ways. I'd like to put the tread on last. You could put the tread on first. I don't think it really matters. The first thing I'm going to do is get the bevel gear attached to the wheel. So we'll open the bevel gear up here. And if you look at the wheel, there is one side has sort of this sticking out pattern. It's that 6-hole kind of, I don't know, star or flower shaped pattern. If you look at the other side, it's not really there. It's all the way down to the spokes is the first thing you can see. So what we want to do is on the side with that pattern, that is where we're going to drop in our bevel gear. And the bevel gear has a machined section here that's going to fit inside the center hole. And when we do that, you do want to try to keep the holes lined up. So if you look through, we want to line the holes up with the holes that are on the wheel when you go to put it in. And it should just go in by pressing it, wiggling it in, whichever side is sticking out. But you can, of course, put it down on the table and give it a couple taps if you feel like it's not going. Now, the tricky part is, looking inside there, my holes right now are slightly misaligned. But I've found with these, once they're hammered in all the way or once they're in and flat, you can rotate this pretty easily. If you can't rotate it and you can't turn it to get the things lined up, what you can do is if you flip it over, you'll need to find something that fits through here. Ideally wood or plastic, something soft. But in a pinch, you could use something like this standoff, which is aluminum. You could put this in, you could tap it, then you got to move to the other side and tap it. And in that way, just like we wiggled it in by pressing on opposite sides, you can pound it out by pressing on opposite sides. But this one now, after tapping it in and spinning it a little bit, seems to go in very nicely once it's flat and level, it seems to go really well. So we are in there. I'm going to spin it so the holes line up. We're going to do 6 holes with 6 of, actually we're coming from the other side. So another thing to notice on this one is all of these bolts that we just took out, those are for the tread. The holes are tapped in the bevel gear itself, which means that's where the threading is that we're going to screw into. So we're going to actually start on the back side of this. We're going to go through the spoke first and then screw into the bevel gear. And the gears we're looking at to do that, or the bolts we're looking at to do that are, these are, again, 1032s. They are 1 inch long, but these are socket head bolts now. So we're going to go back up to that 5/32 size, which will fit in there. And basically, if everything is lined up, we should be able to just drop these in and screw it in. Now, if you have one of these bevel gears that's a little bit sticky that you couldn't get in all the way, you could flip this over and tighten bolts in. You could work in maybe say 3 bolts in a triangle shape, right? So we could do like this one, and this one. You can use the bolts to pull it in all the way flat first. But because mine is in and it is lined up and everything is working well, we are ready to just go ahead and straight attach it, which means we're going to add the Loctite now. If I were doing it the other way, where I was using 3 bolts just to set it, to align it, I would probably not Loctite them. I would tighten those 3 bolts in, then I would do the other 3 bolts Loctited, take the first 3 bolts out, and then add the Loctite on them. My bevel gear fell off. Let's push that back in all the way. Let's be sure it's good. Line it up one more time. Okay, and I'm holding the bevel gear so it doesn't fall out this time. And we'll drop bolt in. And I'm going to get it so it's snug, but I'm going to stop there until I get all 6 bolts started. So another one of those 1 inch bolts. Get it started with some Loctite. And I'm going to add a little more Loctite because I rubbed that all off. But I'm also going to not go right next to the bolt I just put in. So just in case stuff is not sitting flat, the most effective place to go is somewhere on the other side. So I'm actually going to do one of the triangles first. So I'm going to skip a hole and then get this one started. That seems good. And then we'll do one more on the last side of our first triangle here. And this is sort of just like changing a tire on your car. You always kind of do a star pattern or go across the wheel. And that helps, like if it's on an angle, instead of pulling it more on an angle by going across, we're going to pull it back in and flat. So we've got all of those started. Let's go ahead and start the other triangle now, the other 3 bolts. Okay, 1 and 2. And the 3rd one. Okay, now we can go through, and again, we're going to tighten them, but again, we're going to work around those triangles. So I'll do a pull there. And if it doesn't get tight with like, you know, about 1/4 of an inch or an 1/8 of a 1/4 of a turn, 1/8 of a turn, just move on and do the next one. Then I'm going to do the other triangle. And you could probably get away with just making them be tight and going in a circular pattern. This way just guarantees it's going to sit flat. So now I'm going to go back around and do all 6 bolts again with one more tug. So the idea was the first one was pulling it the rest of the way flat if it wasn't sitting all the way flat already. And now we're just making sure every bolt is tight. Like that one got a little bit looser and I had more room to pull it. So as we tighten the other bolts, we brought that corner in a little bit and that found more space for us to tighten. Okay, so once those are all in, you can go ahead and check one more time if you're worried. For me, I think we're good. Those feel tight now and it's not moving anymore. Okay, you do want to kind of try to look inside of here or feel inside. I can kind of get a pinky in there, but I want to feel and make sure there's no gap between, you know, that flower pattern or that star pattern on the wheel and the back of the bevel gear that we put in. So you're just feeling that there's no gap. And again, there shouldn't be a gap because we did the whole star pattern, do the triangle, do the other triangle as we tighten stuff in. You can also kind of see on the front, all of the bolts should look about the same. If one of them is in a lot and others are not in very much, that's another sign that you might want to go back and check and make sure it's sitting flat. All right. Then I think the next thing is you could put your bearings in now. Sometimes, depending on how tight they are, they might fall out as we put the tread on. So I'm actually going to wait on the bearings and go ahead and do the tread next. All right, so we've got our long tread here. On the wheel, there is a section where there are 4 holes really close together. So normally, it's just like 2 holes going across. But in this section right here, there's 4 all together. And that is the starting point and the stopping point for our tread. So we have, 2 sets of bolts holding the tread ends down. OK, so we're going to start there and we're going to end there. So find that section. Then the next thing that you want to do is get the bolts. I like to get all the bolts through the tread first. You could do it 2 at a time if you prefer, but I like to get them all in. And I find that it is a little rough to do it by hand. So these, again, are still just 1032 bolts. You can use the Allen wrench. And I like to sort of wiggle it a little bit. You can try screwing it in, but usually for me, wiggling it will get it so that it's poking out the other side. And as long as we have some of it poking out the other side, then we're ready to kind of move on to the next one. If you do have like a handled Allen wrench or hex key, like that is all this is the handle for this. I find sometimes having the handle is a little bit easier to get these started. And also to kind of get them lined up when we go to screw them in. So I'm going to go ahead and use that for the rest of these. If, when you're doing this, any of the holes are really loose and it feels like the bolt might fall out as we're working on stuff, then just go ahead and skip that one, because it'll be easy to add in later. The idea for why I want to put these bolts in now, while everything is free, it's just easy to access. And so for some of these where you really have to fight to get the bolt to pop through, that would be harder if you imagine the wheel was hanging on here and you have less room to work. Okay, but these are going in pretty nicely. That is, like I said, one of the benefits to buying the pre-made one is the holes are opened up a little bit more than sometimes they are when you custom make them. But once you figure out your process, you can probably also do the same thing. All right, last 2 bolts here. And all right, we are ready now. So for these especially too, we are going to want to Loctite these in because these bolts loosening up, like if the bolts were sitting out this much when you went to go driving, the bolts are actually higher than the tread. So the bolts are going to be what you're driving on. Those bolts are going to dig into the carpet, into the floors, whatever you're driving on. That's not going to be a great situation. So we don't want these to loosen up. So for sure, we're going to add Loctite. And I'm going to do both of basically 2 bolts at a time with the Loctite here. You can also, especially early, you can do the drops into the holes. That gets harder, you'll see, as we attach the belt and it gets in the way. All right? And you can sort of feel like if you push this tread, you can sort of feel like when it's in those holes. And when it's in the holes, then you can start to screw it in. You can also see from the side the direction it is. Now the first one's pretty easy. And I like to get them both started a little bit before final tightness. The first one's kind of easy though because we can be tangent to the holes. We can be flat against those holes. The next ones are going to be harder because as we wrap this stuff around, everything is going to want to be on a little bit of an angle and we're going to have to fight with it. Okay, so now those are both started. I'm going to tighten them in. Actually switch to the regular Allen wrench here. I really want to get these sunk below the surface of the tread material. But know that if you keep screwing these in, they'll keep digging deeper and deeper and deeper. And at some point, you will have gone too far. So what I'm looking for is something that looks about like that. If I run my finger over the top, that bolt is not hitting. There is some squish around it. You can definitely see some deformation of the treads around it as those squish in. And you might see some bump here on the end that we don't have to worry about. But just make sure they're sunk down below below the tread. And you'll also feel, it does start to get tight at that point, but you can force them and you can start digging down into the rubber, like you can expand the rubber hole, then you can kind of sort of dig through the backing material as well. All right, so those two are done. Next two, I'm gonna add Loctite. I'll go ahead and do this one in the hole instead. In the hole, sometimes it's a little bit harder to tell if you got a good amount in there. Now you can see when I bring this tread around, those bolts are going to be on a little bit of an angle naturally, pointing away from the hole. So we need to really work to make the hole as straight as possible before we start screwing this in. If you do it when it's on an angle, the issue is that you would be basically cross-threading the hole. There's a chance that you cross-thread the hole. So when you're screwing this in, if the beginning doesn't go relatively easily, stop and start over. Okay. And again, I also like pulling the tread to help get it lined up is helpful too. Okay, so we'll screw those in. Now that they're both started, we can take them down to roughly the same amount as the first ones. Seems pretty good. And that seems pretty good. All right, next set. Do the Loctite on the bolts this time. Not for any particular reason, but just because. All right, and then we got to get those lined up. And you'll see too, the farther you get, the harder it is to kind of get those bolts to line up. This one especially, you can see, is just really crooked to the hole. So the bolt is sort of like on this angle, the hole wants to be on this angle. So I'm going to definitely have to pull, kind of push and pull the bolt around to get it to line up. Okay, and that one feels really tight as I was tightening it in. That means I probably didn't get it quite far enough and we were cross-threading it. There we go. So again, it should be relatively easy to screw in. If you feel it fighting you a lot, back it out, try again. All right, and we'll get this side now. Same issue. We got to really pull it out. I do like this angle though, because you can sort of see the nub inside where the threads are. So you can use that to sort of help align the screw angle as well if you look from that angle. All right, screw this one in. And then let's go ahead and take these down to their final depth here. And a little more. Looks good. Okay, last holes. I'll do this one in the hole again. All right. And this one might be the hardest one to get lined up because you have less stuff to kind of pull on. But by using the tool, you definitely get the ability to sort of change the angle here. That one seems pretty good. Okay. And the other side. Looks good. All right, and let's tighten these in. Okay, and you might see when you're done, there might be some bowing here. It might look like there's a little bit of a bump between the thread at the end, or the tread at the end there. You don't have to worry about it. Like if you put it down on the table and you roll it, you will probably barely be able to feel it even when it's going over that bump. And don't forget, we run on carpet for the events, so even more so, it's going to be some extra compliance that takes care of those problems for you. All right, next, it is time for the bearings. So we'll line those bearings up. These are the last remaining bearings, but they're flangeless, and again, they will fit perfectly on the outside or on the inside of these holes. That one went in really easily. This one feels a little tight. So maybe best thing to do, that one just fell out, so I'll leave that one off on the side. We'll do this one first. And I'm going to need to tap it, again, aiming for the side that's sticking up, the highest, so that it goes in as level as possible. All right, and this should end basically flat with the outside of the wheel there. All right, so you want to make sure that goes in all the way. If this is sticking out a little bit, that is going to make it hard when we go to drop it inside our forks here. So if those bearings are sticking out at all, that's going to make life harder. So make sure that's in all the way. We'll come back through. Let's get the other one back in, and that one just dropped in, so we know that one's good. All right, then we have one more piece here. This is our wheel shaft. And this should go right through both of those bearings. Now, if this doesn't move smoothly through the two bearings, you should stop and make sure that they're pressed all the way in. The biggest thing is, like, if it's not all the way in and it's on a tiny bit of an angle, if like one corner needs to get tapped the rest of the way in, that will misalign the holes and make this not sit nicely. All right, then once it is nice and everything is looking good, we are ready to bring our wheel into the rest of our corner assembly here. Now, what we're looking for is, there is the side that has the gear, the bevel gear on it. And that bevel gear and the bevel gear on the wheel need to mesh together. So that's the direction we're going to face it. This axle, too, the shaft that we're using here, is going to end up sitting nicely in between the two forks like this. So you can see that without the wheel there. All right? So once again, yep, my bearing popped out again. All right, cool. So we're going to take that gear, face the gears together, and try to line it up. If you can't get it to go in, if it doesn't drop in nicely like mine did, you might have to loosen these forks up a little bit. Remember, we left those loose just so that this drops in a little bit easier. At this point, you should be able to turn this and it should feel relatively smooth. If not, we're going to double check that everything is aligned before dropping it in again. Now, we can take our bolt. So this is our long wheel bolt. This is this is a 1/4-inch bolt now. And it is, I don't know, it's long. It should be the only one that's remotely close to this, but it is let's say 3.5 inches long. And this is going to go through the center of that shaft we just put in. So it'll go all the way through here. I don't think it matters which side you start on. I'm going to start on the side without the bevel gear and push that all the way through. You can see now it's poking out on the side with the bevel gear. And I'm just going to back it out a little bit because we have the nut that is going to fit perfectly in that. If you remember, the hole here sort of had a couple of the corners of the hex shape from the bolt. So this is going to sit nicely in there. And that actually will act as our wrench. We don't need a wrench to hold this side. When using nylock, so first of all, this is a nylock nut. That means that there's a little bit of nylon plastic on the inside. That's the white bit that you can see. That is there to help keep this nut from loosening up, or the bolt from loosening up. So instead of Loctite, what's going to happen is this bolt is going to dig into that plastic. It's going to cut into that plastic, and that plastic is what's going to lock it in place. So this step, we don't need to use any Loctite for this bolt. The other thing is, one side you can see the plastic, one side is just all metal. So if you haven't worked with nylocks before, make sure the all metal side is facing in when you line this up to screw it in. Okay, so that's facing in. Now we can start screwing in this bolt, and it will go into that nut. And as long as I if I push forward, you see now it's not in the spot anymore, and the nut is spinning in place instead of tightening. So I'm going to use one finger to keep that in place, and then I can go ahead and tighten the bolt down. And if you're running into trouble like, oh man, I can't turn the Allen wrench anymore, remember, the wheel steers. So turn the wheel so that it's either flat towards this edge or this edge, and then that hex key is going to fit nicely. And if you tip the whole thing up, always watch the wires when you're working though, but if you tip the whole thing up on its side like this, then you have room to swing this around without having to reset it too. All right, and we'll go until that's tight, and then stop. we're going to check again now, make sure that it spins relatively freely. You can potentially over-tighten that to the point where it doesn't spin nicely anymore. Mine is good kind of to this tightness, maybe even a little bit more. So it shouldn't matter because tightening down will crush it into the standoff that was inside here, that wheel axle. And so it should be good. But if something is a little bit off, you might want to just back this off a tiny bit. As long as the bolt isn't really rattling back and forth much, and you're engaged on the nylock, it's not going to fall out. Now, remember the forks. We have the two forks, this side and this side. The bolts there are they're loose, first of all, and they're not Loctited. So now we got to go back and we got to do the thing that I said we would do later. So just pick one of the bolts, your choice, unscrew it. Okay, we'll take that bolt out. And then we're going to add Loctite and then put it back in. And I'm going to go until sort of like spinning it hits the bottom, but I'm not going to really tighten it at all. I want to make sure that I can get all of the bolts in, and then we'll go around and we'll tighten them all at the end. All right, next one, Loctite. Drop it in. Okay, and then I'm going to spin it around. So that was the side without the bevel gear. Now we're looking at the side with the bevel gear. Looks good. Tighten that one in. And the last one. Okay, and now I'm going to go back and snug them all the rest of the way. Okay, bevel side done, spinning it around. Let's do the non-bevel side. Okay, and once all of those are tight, once again, it should be spinning relatively freely, and it should be spinning the other direction relatively freely. Okay, so if you feel any major snags, first just check the gears and make sure there's nothing stuck on the gears. You can hear there's a little bit of some noise when I do this one. Some of that noise is going to get less too once we grease it. But you should just make sure that you have good spinning on both of the directions here. Okay, and you can even check that from above too. You can sort of, it should roll nicely on the table. And if you spin, again, be careful with gears because they can pinch you. But if you spin this one by hand, right, we should get the wheel to spin nicely on the bottom. And that's looking good. All right. So this is the end of the module if you are not using the lower mount. So if you have your own custom way of attaching this to the rest of your robot, then you're set. But we do have one more piece that we are going to attach, and that is our bottom support plate. And the idea with this is when this gets attached on the bottom, there will be, it'll be a lot easier to show you if I take it out of the plastic bag. So let's go ahead and open these up. Okay, so this will ultimately attach here. And what that's going to do is that's going to give us a channel in between. So when we take our aluminum 1x2 box here, that's going to sit inside. It's going to be in between and be supported on the top and the bottom. So this is just a good way. If you're going to use 1x2 box as the outside frame of your robot, having this bottom support plate is a good way for everything to attach together a little bit more securely. Okay, and so in this package, we've got some other things. We've got two more. These are 2.5-inch long bolts. So really the same as the other ones. I think at this point, we should have, let's check. I think maybe you should have one shorter one left because there was that one step earlier where I had you use a longer one instead of a shorter one. So right now I have one short one. These are all the same as the two that we just added, so it doesn't matter which ones you use. Okay, and what we're looking to do now is when this gets attached, we need something to support here to help hold it. And we're going to also look on the other side to have something supporting it along here. So we'll get those two basically standoffs and bolts holding that together. And then of course when we put in between here that aluminum and bolt the whole thing together, that's also going to be another point of support. So first step is if we look at this from the top, remember the corner is the outside edge of the robot. Let's look for the corner. There's that bolt we put through, and that was the one I said, hey, if you're going to do the bottom plate, go ahead and make this be a 2.5 inch long bolt instead of 2 1/4. And that extra 1/4 inch now is sticking out here that you can see. We have in the kit we just opened up a hexagon-shaped standoff. So this is an aluminum standoff that will actually screw right onto that bit of bolt that we have sticking through. So I'm going to go ahead and add a little bit of Loctite to that bolt and then screw this standoff onto it. And I'll go as far as I can go by hand. And then you can actually grab a wrench to finish that. I'm not 100% sure what size that is. Let's see. It is 3/8. Okay, so you can sort of tighten that. If you feel the bolt moving on the top, you can also hold the bolt on the top with the correct sized Allen wrench, of course, and just snug that in. Okay. Okay, so this piece, one side of it is smooth. There are the holes obviously going through it, but it's nice and flat. The other side, though, has sort of this pocketing. So it has a bunch of material removed to make it lighter. So that side with the pocketing is going to be facing down towards the ground. Remember, the wheel is towards the ground, which means the smooth side is going to be facing towards the rest of our build. So the smooth side is going to go in, and you can line it up to corner. We have the same edges. It's basically the same shape as the piece that's already on there, right? So we're just going to line it up to match that shape. All right, so pocketing side facing down, we'll line it up, and now that standoff we just put in, we're going to be able to screw into that to hold it in place. So what I'm looking for now is the very tiny bolts that just came in this kit. These are 3/8 of an inch, 3/8 of an inch maybe? Yeah, let's say 3/8. So we're going to Loctite that. And then still at 1032, so we still need our 1/8 Allen wrench. And that's going to now go in to the corner hole. So where our standoff is hanging out here on the corner from before, we're going to go through that corner hole on our new plate and screw it right into that standoff. Okay, and this one, again, I'm not going to make it super tight. I still want some adjustment here. We have to attach another piece. We don't want it to be crushed down so it doesn't fit. So again, you can see that bottom section there is sort of matching the middle one that we have here. And we have attached that outside corner standoff. Now we're going to flip it 180, so we're now looking at the middle. This is the flat side here where we attach the motor flat sides. And there is one more hole that runs down here that we're going to attach stuff to. And we have two different standoffs available to us. Basically, check one of the standoffs. If it fits, you're good. The other one is much shorter, so the other one is going to leave a pretty big gap there. That is not the one we want. So the standoff that fits is going to go here. And we're going to bring a bolt. Let me kind of flip this up on its side here. So we're going to bring a bolt up from the bottom again through that standoff. And this one can be, let's see, I think this one should be a 2.5. Yep. You know what? Probably either bolt is going to work. If you still have your 2 1/4 inch bolt from before, yeah, that looks just a little bit short. All right, let's get a 2.5 inch bolt.
and do some Loctite on the end of it. And then we are going to go, where'd my standoff go? There it is. All right, so we're going to go through the plate, the bottom plate, through the standoff, and then this is going to screw into that middle plate. And just to be careful, right, as you screw this in, it is going to stick up above the plate on top of it. So do check the gear that's here. Let's see if we can see that. So there's this gear right here. And then there is the bolt sticking up. So you have the little bit of bolt sticking up here and the gear here. Just look, you can spin it by hand. Make sure it's not hitting. And it shouldn't hit unless this is way the wrong bolt that got put in there. But it is close, so it's worth kind of checking. All right, so now that these are both in and started, we can tighten that one down all the way. And then go back to the other corner. So the outside corner here that we just did. And we're going to tighten that one down all the way as well. All right, so this mechanically is done for our first module. We have a couple things left to add to this, to do to this. We're going to add the wires. You can add the wires now at this step, or you can wait until these are mounted in the frame of the robot to add the wires. It just depends on what your belly pan or floor is going to look like. The one I have leaves access to them, so I could do it later. But on the other hand, it is really easy to get to the wires now. So we'll go ahead and add these wires before we assemble everything. And then the other thing we're going to do before we put this into the frame, until we build it into the robot, is we want to grease all of the gears. So I can put away my Loctite. We are good with that for now. But if I go back into the Kraken boxes, there are some wires there. And there's also a little cover and some screws. Now, for this robot, because it's, again, just a drivable chassis, everything is really flat, everything is going to connect really easily. None of the wires have to go very far. The wires that are in here are long enough, I think, for me to attach everything together to where I want it. But if you have, a much bigger robot, if your power distribution hub is not reachable from where these motors are with this length of wire, then I suggest basically making your own wires. So all these wires it's a wire with a crimped on ring terminal and then some heat shrink. So you can make your own version of these wires, and then when we go to attach them, when we go to screw them down onto our Kraken motors, right, you can have any length of wire there that you want. Same thing, you could, if you are looking to save the CAN wires, so CAN wires are going to be the green and yellow wires that have these ends on them, these sort of PWM style ends that you can use to plug stuff together. You can make your own new cables here as well. What I'm going to do is, because I'm using, I have these wires, you can buy more of these wires if you want. The other nice part is the factory crimps from CTRE across the road are going to be pretty good. You don't have to worry about somebody miscrimping them. So I'm going to use these wires, and I'm going to cut them down to the lengths that I need, because I know that they're all shorter than I need. But if you have a longer CAN run, if you have CAN wires that have to go like way up to 4 feet up in the air to the top of your robot, or 2 feet up in the air, and then you got to come back down or whatever, and these wires aren't long enough, it's always better to have less breaks in your wires than more, because more breaks, more connectors is more chances for failure, more places where a failure can happen. Now, if you do want to leave connectors close by, so it's easy to replace the whole motor by just undoing the connectors, you can do that. It's not too bad, again, to unscrew the wires, bring the new motor in, and screw the wires back in. So it's really up to you for how you want to be able to maintain your modules and your robot throughout the season. All right, so one thing that we are going to do, though, is when we go to tighten these wires in, let's go ahead and open up one of these bags here. We'll see our other pieces. So there is inside the bag another baggie with screws. And there are 2 small screws, 2 small big screws, and 2 small long screws. So we have a thin screw, a smaller diameter screw, thicker diameter screw. They're both pretty short. And then we have the long ones. These ones will hold the case on. These are for the CAN wires, and then the bigger ones are for the power wires. And you'll see the case 2 will go on top of the motor. and just protect all of the wires. Keep everything nice and insulated and covered up. So that will end up going on there after we screw the wires in. There is one thing that we recommend you doing, and that is these wires, we want to make sure that they're tightened the right amount. But if you over tighten it, it's going to be a problem too. You can do damage to it. And obviously the Krakens are relatively expensive because the speed controller is built in. So this is not only a motor, but also your controller. So I guess if you look at it that way, they're actually not that expensive overall. But if you break something on it, you are going to have to replace both the motor and the speed controller instead of just the motor. So we want to be extra careful that we are tightening these in the right amount. So there are some tools that Across the Road sells that are torque wrenches that are set to the specific spec that we want to tighten these in. So we have 2 of them that will, of course, be linked in the kit. There's a 0.6 nanometer one and a 0.9 nanometer one. And the way these work is when we're tightening it in, at some point as we tighten it in, you're going to hear it go click. And when it clicks, you can stop. Actually, if you keep going, it's just going to click again. But that means it is tightened to that spec. So for this one, 0.6 nanometers. And that's exactly what we want, sorry, Newton meters. I don't know why I said nanometers. Anyway, so that's what we want. The easiest way for me to use this, though, is I like to take the bit out to get started. And we're going to do our CAN wires on H and L. It is color. We just match the colors, so everything is really easy that way. The other thing, too, is the ring terminals that we're dealing with. It's a little hard to see, but one side is sort of flat, and one side is down a little bit. So if you look at them, it'll look like one side is sort of more even with the back of the wires, and the other side, there's sort of this bulge that sticks up here. The flat side is the side we want to go down towards the motor. It'll sit nicer. If you do it the other way, it will still tighten all the way, and it will still work, but you'll end up actually sort of bending the ring terminal a little bit as you do it. It's a little bit better if you can get the flat side down. So let's go ahead and do that. We'll get one of the small screws, short screws, small diameter, line it up with the hole there, and I'm doing yellow on the H side, which is a yellow H. And I'm going to just twist this in by hand until it gets basically, until I feel it start to tighten up. And I'm going to do the green one as well. Okay, and the only thing you want to watch out for here is the case that we're going to put on top does have a ridge in the middle. So you want to make sure that these wires are pointing far enough out towards the sides that they'll fit to the sides of that ridge. So this one bump here in the middle. So if they're bent too far in, it won't work. They can be bent very far out, but we also want to leave some space for the other wires. I found that basically if they're pointing roughly straight out from the motor case, that works pretty well, give or take a little. So now I'm going to put this back into the tool. Make sure this is the 0.6 Newton meter tool. And put that down on or into one of the screws. And again, I'm going to twist until it clicks. There it goes. So that's as far as we need to go. And this one, same thing. Click. And you can see if I keep going, it's going to click again. But I do think each time you click, it might push a little bit on it. So if it clicks once, stop. Maybe twice, stop. And that is now tightened to this torque spec of 0.6 Newton meters. And you can feel they're tight. They're not going anywhere. So we're good on that. Now, we're going to do the same thing for our power wires. So I'll take the black wire here and line it on the black side. Again, there's a flat side and then the side with the big bump and bulge sticking up. It matters even more on this one because you can see if you go to set this down flat, like it really is going to be on an angle or it's not going to sit flat because it's sitting on the wire instead. But if you turn it over, it will sit nice and flat. So now with this one, I'm going to take the tool out of the 0.9 Newton meter wrench. And I always like to put these back in because if these get switched up, you would be under tightening the big wires and over tightening the little wires. So when you're not actively using it, I like to just keep it stored in there so I don't make any mistakes. So again, I'll take this out of the big one and we'll go ahead and get those wires started as well. Okay, and I'll just stop once it starts getting tight. Get it at an angle I like. And then same thing for our red wire here. I also find it's easier, however you want to do it, but I find it's easier to put the bolt through first. and then line it up by holding the wire instead of trying to hold everything together at once. Okay, back in the tool, and we go till it clicks. Perfect. And now the cover goes on, and the cover uses the two long screws that we have here. And these are the same size. These are Torx bits. This is the same size as the small tool, the 0.6 Newton meter one. So again, I think it's a lot faster if you take it out and you sort of spin it quickly by hand. The case, I don't believe, has a torque spec rating. So these ones, I don't know that they need to be tightened in until it clicks, but I'm going to do it anyway because I like the clicking sound. All right, so now that case is on, we have all of our wires coming out. So that one's looking good. We're going to repeat the same process now on the other side here. So exact same thing, get our wires, get our connector out. And make sure you get the 0.6 one, because that's the only one that will fit these bolts. And here we go. Same thing one more time. Switch those over. There we go. And I'm kind of trying to hold onto the wires so they stay facing the way I want them to face. There we go. Switch over to the bigger one, and let's do the power wires. And torque them to spec. And then the cover. Perfect. All right. Last thing we have to do before we start building and assembling our frame is to grease this. But since that's going to be a messy process, I'm going to clean up the table and come back with just the module and some grease. All right, it's time to add some grease to this thing. Now, the idea is we have all of these gears that are meshing together. And when you have metal rubbing on metal, there's going to be some wear. And eventually, they're going to wear out to the point where they don't engage anymore and you can't actually use the module to drive your robot around. So the fix for that is to add grease. Grease is going to add some lubrication. It's going to reduce the friction, and it's going to help protect the gears so it lasts longer. Now, there are several different types of grease that we can use to put on these gears. The recommendation is all of the top section of gears here, all of these are what we call spur gears, kind of regular gears. These we can use a white lithium grease on. The bottom section, though, down here where, there it is, where the bevel gears are and the bevel gears meet, because of the shape of these gears, they're more likely to kind of throw the grease off and lose track of it or lose it from the teeth surfaces. So for the bevel gear section, the recommendation is to use the red and tacky grease. So we've got some red and tacky grease here. We've got some white lithium grease. If you've ever gotten the KitBot chassis from your kit of parts, I think the little packets that come with that are red and tacky, but just in a small, easy to use container. So if you got some of that left over, that's fine. I think if you only have red and tacky grease, I would not be worried about just using that everywhere. I think it would be totally fine to use that in the top section as well. But we got both types here, so we'll show you how both types work. Okay, so our goal with this is to cover the teeth surfaces, the outside edges of all of the teeth, with some of this grease. And it's also important, I will reiterate this again later probably, but the grease does not last for a whole season. So you're going to grease it, you're going to drive around for a bit. You need to constantly be checking it for when it looks like there's not, any grease left or not enough grease left, and you're going to have to add more grease to it. Other things while we're at it that you're going to want to be looking for too is, when you go through and you're checking for grease, you can also check and make sure all the bolts stay tight, nothing is coming loose, and that everything still looks the way it's supposed to look. And you can do kind of like a test too, like if the robot's up on blocks, does the module still have full 360 degrees of rotation without catching on things? So there's just some of these things that you want to do upkeep-wise. But let's get to the greasing. All right, so there's a few different ways that you can apply this grease. If you have, a packet or a squeezy bottle, you can just sort of squeeze it on a gear and just keep turning the gear. You can use your finger to help spread it out. I'll probably try to use the brush a little bit. That helps too, especially when, otherwise I just have to stick my finger in there and grab it. So the brush I think helps to spread it out as well. You probably want to have a separate brush for both if you're going to do it that way. But let's get started on the top section here. And we can sort of look at this as a few different areas that we need to grease. So first, on the top, like if I spin this gear here, you can see that this gear is spinning, this gear is spinning, and this gear is spinning. So that's sort of 3 gears in a row there that are going. And then a little bit, you can see underneath there's some movement. But for the most part right now, we have these 1, 2, 3 that are going. On this side, if I spin this one, we have 1, 2, and 3. That section up there at the top that's going to go. And then, again, if I spin that one and we look sort of on the inside here, let me see, I can actually spin this one so it ends up coming around to where we can see it. So spinning our steering gear here is going to make the big machine gear here, our rotation gear here, spin. And there's a gear in the back that meshes with that. But then also, when we spin the other one, this bottom gear set here is also moving. So we have to gear the bottom gear, our rotation gear, the aluminum silver one. We've got to gear this bottom section here. We've got to gear both of the top 3 gear sections, and then the bevel gear down here on the bottom. So let's start with, and this is one of the reasons why maybe you would want to skip wires until later. We got to just kind of always be careful about the wires. But we'll go ahead and start with this section here. So we've got these 3 gears that we're going to want to grease. Okay, so we'll do some of the white lithium grease here. I find that usually it seems to be the nicest if, let's see, that seems like that's a good spot for it. All right. For me, it seems like it's usually the best to try to get it on the biggest gear. So we have a small gear here, the biggest gear here, and then another small gear here. If all of the big gear's teeth are covered with enough grease, it will actually transfer to the other gears as we go. So I'm going to just start squeezing this out and turning the gear as I go. Now, just be careful when you're turning these gears by hand. It's not going to hurt you too much, but if you do spin it around too far, you can pinch your fingers in the gear pinch point. So just be careful of that. As we go around and do this. So I'm just going to keep, squeezing a little bit out and spinning it. You can, if you don't have a normal bottle like this, squeezy bottle like this, you might have to wipe it with your finger just to make sure that it's really covering everything. But you'll see too, the section that I've done, if I spin this sort of back and forth, you can see too that it does a pretty good job of spreading it out on all of those teeth. Just by running it, between the other gears. And you can't really add too much grease too easily. If you do add too much grease, what typically will happen is it's gonna fall off. It's gonna end up stuck in places around the module. All right, so I think I've made it all the way around on the big gear. So what I'm going to do now is just spin this around a bunch of times. And this one you can spin. This is our steering gear. So this one I can spin by turning the wheel on the back as well, and that's easier. And if we do that a few times, now I can see that there's sort of like a nice coat of that, off-white color along all the gear teeth. And what I'm looking for is it, down into the grooves of this gear? Is it up at the tip as well? And watch as you spin it, you want to check that, make sure that it got all the way on the pinion gear on the motor. The big gear is kind of where we put it, so we expect that one to be good, and the other small gear down here should get covered as well. And you can actually see, as I've been doing this, a bunch is sort of gathering here. I got like a little section of stuff. That's okay, don't worry about it. You can wipe that excess off as it gathers up. But it's also not going to hurt anything. All right, so that section is good. Now, let me see, I think if I flip it this way, we can work on this next section, which is this gear, and the big gear in the middle. So this one will be a little bit harder to see. Maybe if I get to all the way to the side here, we can work on that big gear right here, as we'll just keep putting some of the grease on and turning. And this one too, you can make move by turning the wheel itself instead of the motor, if that's easier for you. Okay, that looks like we are back around. So now, we're just going to spin the wheel and try to spread that grease out. Okay, that looks pretty good. Again, you can look up here on the motor, and that has gotten some grease on it. If you feel like it's maybe not transferring all the way to the motor, you could add a little bit more up on the motor side. And you would have to go all the way around the gear, because if you only add it in one place, well, eventually it'll work its way over there. That looks good. Okay, that's pretty well geared. Now the next place we're looking is the biggest silver gear here, and then we've got the little gear here on top of it. So this is another one of the turning ones. So we've got this gear right there, and then the one below it. It's maybe accessible here, so we could do it this way. Also, you could, if we spin it around, right, we have really good access to that big gear here. So we'll just have to spin it back around and check to make sure it got onto the little gear afterwards. Okay, so let's just start adding grease. Some extra there. All right. And this is the biggest gear, so it will take a little while to get all the way around. There we are. All right, and so now this one again is turning the wheel. So she's going to turn the wheel a bunch. You can see we got quite a bit of extra buildup here. So I will go in and I'll wipe some of that off. Again, it's not going to hurt anything. If I just ignored that, it would be totally fine. All right, and then let's spin it around so we can go back to the other side. So this is the other gear here that we needed to get covered, and that is pretty covered. Actually, might have added slightly more than we need for this one, but that looks good. All right, so that one is all set. There was one more gear on the inside here that we have to look for, and that was this one. So there is that middle section there, which is this gear here, and then the very inside gear. You can control the position of the little gear by rotating the wheel. So if that gear is hiding and you don't want it to be, you can rotate that out. I'm going to put it down like there, I think. And then I can go in and add some grease on this gear here. And do your best to spread it out as much as possible. But I mean, by now you've seen once you start spinning it, it also does a pretty good job of helping you spread everything out. So let's go ahead and spin that. So this one is spinning the wheel. So we'll do that a bunch of times. Get that grease spread out. So it looks like, that looks pretty good. It's like this area, it's covered. All right, so that is the whole top section greased up and looking good. Now we've got to do the bottom section, the bevel gear section, where we've got to use the red and tacky. Okay, so let's flip it around. There we go. We can get access to it. I think we can see it the best this way. All right, but not be on the wires. Okay. So now we have the bevel gear down here that's going to spin around, and the mating bevel gear here that we need to get coated. And these ones too, I think wear on bevel gears, especially if anything is at all misaligned, it can go bad faster. So you definitely want to make sure you're keeping an eye on this grease here. So again, if you just have your fingers, you can get some of this and you can put it on the gear face and just keep rotating and keep doing that. Because I have a little brush, I'll use this. This is just a chip brush. You could use a paintbrush, but chip brushes are usually really cheap. The only thing I do is I sort of tug on them a little bit at the beginning because a lot of the hairs will come off of the cheap chip brushes, and it probably won't hurt anything really if it gets stuck in there, but it's nice to keep some debris out. Actually, by the time you run this in an event, you'll have plenty of carpet fibers in there anyway. So let's get some of that grease on our brush here. And I'm just going to brush it on while we're rotating. Get some more. And more. All right, and then we're just going to spin it for a little bit. Get that worked in. All right, and that's looking pretty good. You can see there's a decent amount on the inside of the area here of the bevel gear. And this is what will happen. So that excess grease is going to end up just kind of finding a place for it to fall off. Let's check the other gear and make sure that it has really good coverage as well. And yeah, that looks good. Okay, so final checks now. And you can kind of do this on the table, but really I just want to roll it now. We did this earlier, but just rolling that wheel, you can do it by hand. It should feel very smooth now. A lot of that, if there was any sort of little bits of stuff that maybe you were feeling before, the grease should help smooth that out. And same thing when rotating it. So this one feels really smooth all the way. I don't feel it getting snagged or caught anywhere. If you do feel it getting snagged or caught, there's a few things you can try. First step is probably just inspect. Look at the gears. Do you see anything caught in there? Because it's easy for, bits of paper towel to get caught in there. And every time that piece of paper goes by, you're going to feel it get caught. Double check, that the bolts are in everywhere, that everything is snug, the bearings are seated. And if it still feels rough at that point, you might have to disassemble and then reassemble it, seeing if you can find anything that was not in place. But again, I did 5 of these now, and they have all been nice and smooth once I got everything bolted in. Okay, so I've got all of the parts to put together one of our X2 non-inverted Swerve modules. Of course, all of these parts were before on an X2i that we filmed last year. So it's disassembled. So you're going to see some signs of grease, maybe some signs of usage on these parts. And except for the conversion parts, they're not going to be in bags and labeled. So I won't be able to tell you what the bag was labeled, but I will try to call out the piece that we're using. And the good news is the assembly of this is very similar in a lot of ways to the assembly of the other one. So the wheel part, going to be exactly the same. Our first initial plate and big bearing, that's all going to be the same. The only difference is when we get to the plate that goes on top and attached to the motors, we're not going to have that extra motor plate and all of those extra gears. So this should be a simpler and faster assembly. All right, let's get started. I've got all the Allen wrenches I was using before and the retaining ring
pliers here. And that should be everything we need. Got the Loctite as well. All right, so first thing is we need to find our top plate. And just like before, because we're going to be using a top plate and a bottom plate, the top plate, right, is it's got the ring with a little bit of a lip inside, and between the two holes, it is the smaller of the two holes. So make sure we get the right one of those. And what we want to do is find our giant bearing, and we're going to put that bearing into the spot. Again, facing the same way. I believe we're going to have the balls facing up, and then the groove facing down, or the guide facing down. Okay, and just like the last time, ideally we can get this to go without tools, just by pushing on opposite sides here. If we can get it to go in straight, that usually helps. All right. This side is sticking up. This side is sticking up. Can I get it to move? No. All right, I'm going to grab a mallet here, and we'll give it some gentle taps. Again, I definitely don't want to damage this bearing, so we're giving it the most gentle taps that we can. I think that's in all the way. We'll go all the way around one more time. All right. Yep. And you can check your bearing, make sure it still spins nice and freely. That's what we want to see. Okay, next up, we're going to get this ring, kind of the retaining plate, and that is going to line up on all 5 of the holes. And then, just like before, we're going to Loctite everything as we put it together. So just a little drop of that. And let's see, I think this is a 1/8 Allen wrench. I also have it in my handled one. So I'm going to use the handled one because that is going to be faster for all of these repeated ones. So each one, get a little drop of Loctite on it. Same thing that we did. I mean, this is exactly the same set as we did before, or step as we did before, so we'll rush through it. I'm actually just going to add the drop of Loctite into each hole, because then I can add it all at once. And I can zoom through this a little bit faster. Right, and the reminder is don't tighten any of them down until you get them all started. So I'm going to get them all close but not tight. Okay, now we go back through and tighten them down. With that one really loose. All right. So that was step 1. We now have that in. I can wipe off any of the excess Loctite that came through the other side. All right. Next up, we are going to open our, so this is the WCP Swerve X2 base kit plate. This is what we're getting as part of our conversion kits. So if you're one of those teams, that's what you're looking for. We're going to save our standoffs for a little bit later. Okay, and in this, we're looking to put one big bearing in the middle. All right, so this is going to be the biggest bearing that we have. It is going to eventually be for the size of, we have this shaft with the magnet in it. That's the one that it's going to fit on. So you can check it out that way. Also, it is flanged. So we've got that extra lip on the side. That's going to stop it from falling through. Okay, and then we need to get ourselves oriented kind of on these plates. So on this plate, one side is completely flat. The other side is still pretty flat, but it has one raised section here on the side. The side that has that raised section is the side that we're going to put the bearing in from. So we're going to put the bearing right into the middle hole. And again, hopefully it just slides in. Mine did. So again, try to work it, push it a little bit on each side if you can. Try to get it to go in flat. If you have to tap it, you can, but try to get it going first without. All right, that's good. Next up is we're going to get this gear. This is our big, it's kind of milled out gear. And we have two different sides. They look very different. So this side has kind of like some spokes coming out. This side has like a big square, or I guess rectangle, milled out of the middle here. So get the side where the square is milled out. And we're looking for our next bearing. This one also is flanged, so it has that extra lip on it. And what we're looking to do with this one is to put it into the hole. In between, we got two screw holes here on the side, and we want this bearing to fit in. So if it fits in the hole and it's flanged, it's probably the correct one. You'll know for sure if you get this piece. This is our like bevel gear shaft. That should fit into it nicely, which incidentally is the next piece. But I'm going to actually bring this up. Let's see, up from the bottom. Can we put this in? I can't remember if we can put this in after. We totally can. Yeah, OK, cool. All right, so eventually the round section of this, the side that we put the bearing through, and where we're going to put this gear through, that's going to eventually face down and go through our bearing here. But it's cool because I can do that after it's already attached. So next step is we're going to get our gear. And this one is going to be based on the size that you chose, or the gear ratio that you chose when you're doing the X2Is. So I'm using, this is, I think, a 16 tooth gear. So I was doing 10 to 16s. I used kind of the lowest ratio. You might have a slightly different size, but remember this one has sort of the two raised bosses on either side. So you can see there's an extra little hub kind of sticking out on each side. And it's got that hex size that is going to fit onto this. And it doesn't matter which side you have it facing. It's symmetrical, so you can drop that on. And then on top of this, we have to do our retaining clip. And once again, for this one, if you have the retaining ring pliers, great. If you don't, use the little trick I showed you in the inverted video, but I have my retaining ring pliers here, so I'm going to get that on. And then, as always, I have lost one of these. I'm going to definitely keep my thumb on there so it can't run away and escape on me. And we'll get that down into the groove, check to make sure it's not able to move and come off, and that looks good. All right, now on this plate, before we drop it in, we have the side where we bolted in that retaining clip ring to hold the bearing in place. That should be facing down. Okay, so this side where there are no bolts, that's up. And this gear, the way we have it, with the bevel gear is going to be sticking down through our bearing. So when you push that in, again, this is the same as what we were doing in the previous step with the eyes. That is going to spin nice and freely. If you hear it scraping or rubbing, you might have put it down on the side where it's rubbing on those bolt heads. So it shouldn't make any noise really here. Well, it'll make a little bit of noise, but that should spin nice and smoothly. All right, then if we flip it around, so we're looking at the bevel gear side. On the inside here, we have these holes, two holes next to the bevel gear. Let's see if we can get that one around too. So we got two next to the bevel gear and two on the opposite side. And those are going to be for our wheel forks. So we have these two wheel fork pieces. They look almost the same, but there is a small difference, and that is in this area right here. So this one is sort of a rectangular cutout, and it's flat on the bottom. This one has the same rectangular cutout, but there is an extra circle on the bottom, and that is for another bearing. So we're looking for this tiny bearing. Now, there are three bearings that are this size, but the hole in the middle is a different size. So we need the smallest size hole, but you can check it. If you look at the bevel gear that's sticking out here, that little bit on the end of the bevel gear is what this bearing is going to rest on. So if you check it and it fits nicely on that piece, then it's the right one. All right, so we're going to take that into the fork with the hole, and we're going to do our best to kind of push that down into the hole here. And if we're lucky, we'll be able to just push it in by hand. That went. Again, if you have to tap it, just like we talked about in the inverted video, you got to get a piece of wood or piece of plastic that you can use to extend it. Try not to hit it with metal. Okay, now this is going to come down. So the round part on the outside is going to rest against the bearing. So when you slide this down, that round part is going to be facing out. And then the flat, smooth side is going to be to the inside. And that's the same thing on the other side. So both of our wheel forks are going to go in like that. Now you're looking for these are 1032, these are socket head bolts. So instead of that rounded button head, we have more of a cylinder on top. These are 1.5 inches long, and we're going to do 4 of them. 1, 2, 3, 4. Now with these, there's a good chance I'm going to have to loosen them up later. So just like we talked about on the inverted modules, I'm going to get these going, but I'm not going to tighten them in all the way. And these, because they're socket heads, are going to be a 5/32 Allen wrench instead of the 1/8. So I'm going to get them in, but not 100% tight. There's a good chance that we're going to be loosening these up just a little bit to get the wheel axle in. And then we'll probably end up taking it, the bolts all the way out one at a time to Loctite them in as we go. All right, that is looking good. All right, next step. We're looking for our big double gear. So we have kind of 2 sets of double gears here. We need the bigger one. And on this one here, we've got kind of 2 recessed holes on the inside. And that's going to fit some bearings. And we've got these bearings that are going to fit. These do not have a flange. And they are very big on the center hole diameter. And again, it's going to be for that shaft with a magnet in it. Is going to fit onto that. Okay. So that's what you can check for the sizing. Now that magnet makes it a little tricky, but we're going to push down one gear or one bearing on each side of that. All right, that looks good. And then we can set this off to the side for a second. Let's bring back the piece we were working on. And we're now looking for that shaft that I've been talking about. So that has this hexagon shape. It's sort of like a rounded hexagon. Actually, we have 4 sides of a hexagon, and then the last 2 sides is just a round corner. And it's got a hole in the middle, and then the top has that magnet. And on our gear, we have a cutout that matches that shape. So we've got 4 sides of the hexagon and then the round section. And this is going to be able to sit down into that part on our gear. And then what we're looking for is up from the bottom, we're going to take this is a 1/4 20, maybe a 1/4 28 bolt. Can't really tell the thread, but this is a bigger diameter bolt than the other ones we're using. And let's get ourselves a drop of Loctite on that. Cool. And this is going to screw in. If I flip this over, it's going to screw in through that one main hole on the bottom of this gear up into that shaft with the magnet and the funny shaped hex. So we'll go ahead and tighten that down. And get it just as tight as you can. But you are going to have to hold the gear to stop the gear from twisting, or you can hold on to the forks to be able to tighten that in. And it's going to move a little bit on you. That's another reason why we really want Loctite on this one, because it's hard to make it super tight. All right, now if we flip this over, we're going to take that gear section that we just built, and that is going to go down onto the shaft. And what we're looking for here is it should mate together with this gear. So if I try to put it on this way, for example, which you got to fight the magnet to get it going, you can already see this gear is sitting on top of that one. So that cannot be the right direction. So we're going to flip it over, and your bearings might fall out. That happens a lot on this piece. That's OK. Once we have it together, they won't be able to. So we're going to flip this over the other way. And now you can see those 2 gears are meshed together. Perfect. All right. And my top bearing popped out. I'm going to kind of push that back in. But also, I've had that pop out because of the magnet. There's this small little ring, this little spacer ring here. This is going to sit on top of this. I'm actually going to not push that bearing back in. It just popped out again. I'm going to leave it like this, because I've had it pop out and send this ring flying, and then I can't find that ring. So I'm just going to set the ring on top. We're going to have to push that down when we get to our next plate that we're going to attach here. But we got a few extra steps before we do that. So just leave that there. If you're worried about losing them, you could keep the bearing's not going anywhere because the magnet's holding it, but you could keep this spacer off on the side until you're ready for it. I think as long as my bearing stays out of the magnet, it's not going to go launching. So that's good. All right, I'm going to set that off to the side. Next, we're getting our other double gear. And this is, again, we're still all the same as the inverted setup. So we'll take this gear, and there are 2 bearings. And these are the same bearings we talked about earlier, or the same size bearings we talked about earlier with the wheel fork, except these have the bigger inner diameter hole. And these are going to fit nicely into the top and the bottom of this. If you want to check what they go on, it is going to be this spacer. So we have a bunch of these spacers all over the place here. This one is different because on one end it has a little raised edge. So that end sticks out there a little bit. So that is the thing that's going to go through here. So if you want to check if you have the right bearings, it should fit nicely on that. Let's go ahead and push a bearing in on the other side as well. Perfect, perfect. OK. And now we're going to take this. And if we look back at our setup here, remember that one raised hole? That is the position that this is going to go in. And again, when it goes in there, we want that to mesh with our big silver gear. So if I try to put it this way, it's not going to fit. So the small gear has to go down. And that's what we're looking to line up with. And then our shaft only fits one way. If you try to put the larger size down here, it doesn't fit. The smaller size, though, does fit. So that's what we're looking to do. We're going to take our shaft. We're going to go through the bigger gear side, slide it all the way through so that that bump is going to be stuck on the top next to the big gear side. Then we're going to take all of this, rest that little bit of shaft that's sticking out into the raised area there, and those gears are going to be meshed together as well. Perfect. All right, now this is ready for us to put our plate onto. So that is the plate that we made. And the bearing, the side with the flange on the bearing, is going to go into that center hole. And then there's the raised bump over here. And that raised bump is going to go onto this shaft. So what we have to do is now it's time to push that bearing in, hold the spacer down as much as we can. And then I'm going to get that started on the center shaft there and make sure I can get the other end onto the other shaft. And this is going to basically sit flat when you're in and good. But everything should still spin. So you should be able to spin these and get everything to spin. That's going to be kind of your indicator that everything is lined up nicely. All right, and now we need to bolt this top plate down to the bottom plate. And I'm going to get a few different things. First thing that we need is in our bag here, we've got some more spacers and some more small bolts. We need the spacers right now. We do not need the small bolts for a little bit. We'll save those for a later step. OK, and you should have at least one more of the same size spacer from the inverted kit if you're going that way. So we're looking for 3 of these spacers. These look like they are 2 inches, about 2 inches, just under 2 inches. And then we're looking for these bolts. Now, if you're doing the bottom plate, which is what we're going to do in this video, so this is going to get put together, then there's going to be another plate on the bottom like this. If you're doing the bottom plate, then you want to follow along. If you're doing it as a top plate or you're not using it at all, then you will need to use a slightly different length bolt for one of the steps. So what I've got is I have 3 bolts that are 2 1/4 inches long, and I have one longer bolt, which is going to help connect that bottom plate. This one's 2 1/2 inches long. Let's start with a 2 1/4 inch long bolt. And I'm going to get a little drop of the Loctite on there. And this is going to go right through that shaft that has those gears on it. So I'm going to find the hole on the top, drop the bolt all the way through, and then we're going to go ahead and tighten that one down. But just like before, I'm going to get it close, but not super tight, so I can still wiggle this whole top plate a little bit. I want to make sure everything stays lined up. All right, then what we kind of want to do is get another one of the 2 1/4 inch long bolts. I'm going to Loctite that as well. Cool. Now, if you kind of go out to the corner of this plate and then along the side, so we have this kind of cutout here, there is one hole on a corner that's part of that cutout. And those are the holes where we're going to put a spacer underneath and drop these bolts through and screw them in. So I'm going to do one there and one on this side as well. Can't forget the Loctite. Okay. So we get those close. All right, and then the last one just like when we did the full assembly on the X2Is, this one, we want this bolt to stick through the bottom, because when it sticks through on the bottom, we're going to be able to take another spacer standoff to connect to our bottom plate. So we need that extra length on this bolt to do it. Now, because of that, this bolt, you can see, is going to stick way out the bottom. You could probably still put a drop of Loctite right on the very bottom and have it work. But for this one, I'm going to put it just a little bit higher up on it. So kind of towards the area where I know it's going to end up in the threads. Okay, and then we'll take our spacer, line that up on that corner. So this is the final, this is the rounded corner. Opposite, basically go diagonal from the first gears we put in, which are over here. And that is this corner. This is the outside corner of the whole plate. All right, and then we'll get that one in. And now that all 4 of these are in, we can go back through now and tighten them all down all the way. So we always like to leave things loose so that, plates have room to shift a little bit to make sure everything can be lined up. And now that that has happened, we can tighten them all down. All right, perfect. So this is kind of ready now for us to get our motors attached and our sensor as well. So let's do that next. I think we can do this kind of in any order, but we have our Cancoder. And mine is already attached to the backing plate here. So remember, we just did this in the X2I video. If you don't remember how to get the Cancoders mounted on the plastic plate, go back, scroll back in that part of that video and rewatch that. But we're going to take this, and in the middle of this plate, there are 2 holes. Actually, there's 3. We're missing 1 hole to make a full square. This is going to attach onto 2 of those holes. Now, here's the thing. We can have it attached this direction, or we can have it attached this direction. And if we want to think about this, if we take, of course, I have the one that I showed you in the intro that's already finished. What's going to happen is these 2 modules are going to be the front of our robot. And then our big intake is going to go in between them. What we want is to have the wires not pointing out towards the front of the robot where there's no room for them. We want them going back so they can go back into the robot where we can get back to the rest of the electronics, or at least have a protected place to connect those wires up. So you're going to build one of them, which is this one is already built that way. So if it were this side, right, I would want it attached this way with the wires coming back from the front edge. And then this one, which is going to be on the other side, right, so I got to rotate that over so it's the other corner. This one I want to mount this way. So you're going to have these 2. They're going to be mounted opposite directions. Now, don't worry too much. If you do get it wrong, you'll be able to always go back and adjust it later. All right, and this is going to be 1032s, button heads. These are about 1/2 inch long, it looks like. And they should slide through this plate here, no problem. And then we're going to screw it down on those 2 diagonal holes. All right, get them both started, then you can tighten them down. This one, this is like a plastic 3D printed piece, so I'm not trying to make this super duper tight. So for the handled Allen wrench, or the L-shaped Allen wrench, if I do the long side in and I'm twisting on the short side, it's kind of like that's tight enough. I don't need to then go in and really yank on that, because you can crush the plastic down. All right, let me get rid of the other module here. Next up is our motors. So we're going to get our 2 motors here. And we're doing the same thing on both motors, so we'll do it kind of at the same pace. Now, this is a little bit different from the inverted one. So if you remember on the inverted ones, we took the gear and we put the gear on first, and then we put the spacers on. This one's going to be the opposite direction. So first step is to take those plastic spacers. We're going to do 2 of them, slide them onto your motor. We'll do for both. And then remember, make sure you get the mating gear to the gear set that you're using. I am using the same gears that I used for the inverted ones. I believe these are 10-tooth gears. Yeah, that's what is labeled on them. So the gear is going to go on next. And if you chose a faster gear ratio, right, then cool. Just make sure you get the correct gear to go along with that. And then we're going to go ahead and find the attached washer, like the super wide head bolts These are the ones that screw in on the end to hold everything together. So this part is the same. They actually come with a little patch of Loctite already on them, I believe. So if yours has like the little blue showing, usually that means you're good to just screw them in. If you don't see it, or if you've used them before and you've taken them out and put them back in a bunch, you could add a little bit more Loctite just to make sure. So we're going to get that started. We're going to get it started. There we go. You just have to say it in a way that it believes you. And what's going to happen with this is, like, as I'm screwing this in, at some point, it's going to want to rotate the motor shaft. So I'll hold on to this as much as I can. And it looks like that's basically tight. So you're probably good there if you do that as much as possible and you don't see a gap. The Loctite's going to help hold it in place. If it doesn't feel like that's working, once again, you can use something to protect the teeth. So if I do that cloth there and then I grab onto it, I basically do not want to damage the teeth, right? And give it a little bit more of a tug. All right, so I think we did the same thing on the previous ones. Let me just get a touch more Loctite on here because I know I've used these a few times. And we'll get these ones going. And this one feels like it went down all the way, so I will stop there. Okay, next up is our two, these are, what are they labeled as? WCP 1733. This is the 5/8 L Kraken X60 motor spacer. 60 millimeter OD, 875 inch and nub. All right, we're going to take these out. And again, we're doing the same thing for both of our pieces here. Okay, now, with this, there is two different sides to these. One is flat and smooth. If I flip the other one over, you can see there's a lot of drilled out, milled out pockets. That's the side that we want facing our plate when we put it in. And in fact, actually, this center circle here is going to fit into these two circles that are here and here. It's going to actually press into them and help align it and keep it aligned. So what that means is the flat side is the side that's going to go against our motor. So we're going to take our motor, drop the flat side on, and there are a ton of different holes. So you can kind of line this up however you want. But once again, I'm going to look at sort of the orientation of my robot, right? So I had these wires coming back this direction because this is the outside of the robot. And I want to come back towards the inside here. And then this side is where the intake is going to be. So if the intake is here, we don't want the wires to have to go through the intake. Then with the Kraken, if I kind of drop the axle down into, or the gear down into one of those holes, I can see that my wires, right, are going to come out of the bottom of this CTR thing. The wires come out the flat side. I want that flat side to also sort of be facing back in this direction. Right? So if the front corner is here, I want to be going straight back on this. And if I can mount both of these going straight back like that, that's sort of what we're looking for. Actually, it's going to be in this spot, not in this spot. So it'll be here and here when all is said and done. So key is I want the flat spot facing back. If I take this spacer and I drop it on, so this is going to be, if you find the post where the gear is, the hole right next to that is where one of these is going to go. And if you look at it, there are these two open milled areas here. So this one is like sort of a whole oval trapped in there, and then it's got the edges here. This one has sort of like a milled in thing, but the outside is empty, right? So that section is going to go over the screw head that's here. So that's how I'm kind of lining it up. And then, it's like a teardrop or a football, so the end points of the football are going to line up with these two holes here and here. And that's where we're going to be able to screw that down and into it. But we can't do that first because we have to, otherwise we can't get to the screws for the motor. But if I drop the motor in now, facing straight back, right? So I have that flat part where the wires are going to come out. The wires come out of these little slots back here. If I have that facing straight back, this is sort of like the position I want it to be. So if I take that off now, and I'm kind of keeping them together and not letting it rotate, then now I can look for the holes to line up to screw in. And it would seem as though I have to rotate just a little bit, I think, to here. And now they're lined up. It's really hard to see, but now I have it lined up on the screw holes. Basically, if you take it off to where it was and rotate it as little as possible to get those holes to line up, that's exactly where we want it to be. All right? And then we can use either the screws that we took out, or you should have more of those 1/2-inch 1032 button head screws. And we're going to use these to attach it to the motor. All right, and so once again, let me unscrew my Loctite here, get some Loctite on these. All right, and these are going to go in. Honestly, you can use any of the holes. They all line up. They're all threaded. But I think the instructions say to put them in, there are these slots, right, that we were talking about. And it's going to be the outside hole on those slots. And so that's where I'm going to go ahead and screw them in. But like anywhere there's a threaded hole, I think like on the motor, there is one spot where there's no holes. But if you get a threaded hole showing, you could do it, right? I could do it here and here, or here and here, or wherever, and it's going to work fine. All right, and we'll screw this one in. Okay, and now it's so that I don't forget which one this one is, I'm going to actually put this onto our plate here, our Swerve module. So that's going to use, we need 2 more of the same bolts. These are the 1/2-inch long 1032s. Same bolts we just used to mount the motor. And again, I'm going to drop this motor on so that the gear is down. The teardrop is sort of, and you get a nice, like the edge lines up nicely. It just feels right when you got it lined up. So we're going to push that in all the way. If it doesn't go in, you might have to rotate the gear a little bit just to get the gear teeth to line up. And remember, we want that flat side where the wires are going to come out to mostly be facing back in towards the rest of the robot. Looks like mine is twisted a little bit in. Maybe it would have been slightly better if I twisted it one more hole over. That's going to be OK. Now, on the ends of the teardrop, we have holes. And that is where the next set of bolts are going to go. So we're going to, again, get our Loctite and line that up on the end hole here. We'll get that one started. Okay, and then same thing on the other side. One more little drop here. And now we can tighten those down. And this one probably is a good idea to make sure it's tight. So we'll get that close, switch to the long side, give it a little tug. Give this one a little tug. And then we're ready to look at the next one. Oop. Now the weight balance is different. All right. Get your other motor and the other plate. And again, so they're going to go diagonally across. So this one is going to go, this one went where the gears are. The next one is going to go diagonally across to the outside here. I think you might be able to put this in a different spot if you mount your sensor differently. In fact, maybe you could get it here. Maybe it fits here too. Not with the sensor. All right, yeah, so we're going to go diagonally across to here. And I'm going to just kind of dry fit it, drop this in again. And I want that flat part, facing generally back the same way that this flat part is facing. Then I'll take it off, because that's the direction I know I'm going to want it. Don't let that move. At least don't let it move too much. Okay, and then, let me see. I can't see without adjust. OK, that's the closest hole. So that's the small adjustment to the closest hole. And then we're going to get a little bit of Loctite on there and drop it in. OK, and same thing on the other side. in there. Okay, and these we want tight too. I guess I didn't do this on the first one, but yeah, we should make sure it's all the way tight. Okay, and then knowing that flat spot is going to tell us, right, because we could attach it this way or this way. Line up your flat spots. That'll tell you which direction to go. And again, if you have to rotate the gears a little bit to get it to drop down flat, you can do that. All right, so now that's in. Let me rest that down for a second. You should have two more, or you need to find two more of the same bolts that we've been using this whole time. And we'll get some Loctite on there. Get that one started. All right, and then same thing on the other side. We'll get a little Loctite on that bolt. Drop it in. Okay, kind of get them as tight as you can. Switch. And now we'll do tug with the short side in just to make sure they are in nice and tight. All right, so this section's good. Yeah, let's go ahead and attach the wires now onto our motors here. So this is going to be kind of the same way as on the inverted motors. So I already have my caps here a little bit loose. And remember, we're going to want our torque wrenches. We got the 0.6 and the 0.9. I'm going to take the bit out of the 0.6 just to help me quickly unscrew these things. So close. All right, there we go. Don't lose those screws. And we can kind of do this in either order. But we'll have these Y cables of green and yellow wire. You should have kind of these PWM ends on them. That's great. And then it's labeled on here, right? So we're looking at H, which is labeled in yellow, and L, which is labeled in green. Just make sure you take the yellow one on the yellow side. Same thing, make sure you get the flat side of the connector facing down. And I'm going to tighten that. Well, I'm going to get it close to tight, but I'm not really going to try to tighten it down while I'm doing it with my fingers. And let's get the L1 here started. All right, there we go. Then I can pop this into the torque wrench. And once again, we turn until it clicks. When it clicks, we're good to go. All right, all set on those. And then we'll unscrew the bigger ones. So this is going to be for our motors. Red and black, we have to make sure we get them in the right spot. We cannot reverse these. So for the sim motors that we're talking about later, it's okay to reverse them. But for these, because they're powering the speed controller, which is built into the motor here, we have to get these the right polarity or it'll be a problem. So the minus, I guess the minus is in white, but that is our ground or our black wire. I tried to prop it up on top of something and it didn't work. All right, I think that's a little bit more stable. All right, so let's get that one started. And then the red plus is going to be your red wire. Again, making sure the flat side is facing down. Looks good. Get that in the 0.9 Newton meter torque. And twist until it clicks. Okay, and then we can take the cover. And the cover is going to go back on. You can check too when you put the cover on if it's hitting any of the wires here. Go ahead and adjust the wires. We definitely don't want to be pinching any of our wires when we do that. And then I chose the tool I need to be my stand. All right, so we're gonna go ahead and screw these in. And I think just like we said for the inverted ones when we did this, I don't think there's a torque spec for these. So you can probably just tighten them in as you see fit, but it's just so much fun to get that click that I'm gonna do it anyway. Perfect. All right, this one's done. We got those wires coming out. You've seen me do the inverted ones and this one. I'm gonna do the other one really quickly, and then we'll come back with the next step. All right, we've got the second set of wires now all attached. This is ready to go. We're going to set this aside. We're going to work on our wheels. There are lots of different wheel options you can choose from. I think our kits, and in this video, we're going to be using the aluminum billet wheel. And the next piece we need is our bevel gear here. So on the wheel, there are kind of two sides. We've got one side that has 6 holes, and the other side has nothing. So the side with the 6 holes is the side we're going to put our bevel gear in, and that also has 6 holes. So what we want to do is do our best to line up those holes and push this down into the wheel. And it might be a little tight. You might have to work it in a little bit. It might just drop straight in. If you have to end up tapping that with a hammer, you can do that. That's OK. All right, then what we're going to do is we're going to flip it over. And you can kind of look down through and see if your holes are lined up. Mine are pretty close. Like I can see through them for the most part. If you have to try to turn it, you can. Sometimes it will go. Like mine is turning pretty easily. Yours might be harder to turn. As long as you can get the bolts started, you're going to be OK. And speaking of bolts, we're going to be using these ones. These are looks like 1 inch long, and they're socket heads. So they have that cylindrical head, not the dome kind of rounded off head that we've been using, which means these are going to need your 5/32 hex key. And I am going to Loctite these as we go. So we definitely want to make sure these stay tight. These are actually, I guess nothing, especially on the non-inverted module, nothing is too hard to get to. You just might have to remove a couple. Like for this one, we have to drop the wheel out. So we'll have to take out the main wheel bolt to get to it. But once again, I am going to get all of these started, but not tight. And then we'll go through and we'll tighten them in that star pattern that we did with the inverted ones. A little bit of Loctite on each one. Cool. And now we'll go through and we'll sort of tighten them. Then I'll jump off to the other side, go as far away as I can. And I'm just turning it a little bit at a time. This way, if the bevel gear is not pulled all the way in, we're going to end up pulling it in as we tighten these. And that is going to help pull it in level, right? By us just kind of continually jumping around our triangles here. Basically, go as far away as you can or go on the opposite side each time. I know that one wasn't, but I wanted to check to see if I skipped that one. So we'll do kind of this whole triangle, then we'll jump over and do the other. I guess it's always a triangle. So in this case, I'm referring to an equilateral triangle. OK, and those all now feel pretty tight. So that's not going anywhere. Looks good. Next up, we've got 2 more bearings. These are unflanged bearings. There is a long spacer that is a little bit thicker than all the other spacers we've been using. So up until now, we've been using these tinier spacers. Now we need the bigger one. This is our wheel spacer or wheel shaft, basically. And these bearings should fit on that. That is what's going to end up going through there. We're going to push one into the top of the wheel. And again, usually if you can get it to go, well, that one's getting tight. We'll see if we need to get the hammer or not. I think that's all the way in. Okay. Just a little bit proud of the edge there, just sticking out a tiny bit. All right, we'll flip it over. Same thing on the other side. Oh, and that one goes in easily for me. And our axle then, our shaft, should go through both. And we're just going to kind of check that. That looks good. If your bearings are really loose and they're falling out, that's OK. Don't worry about it. We'll put them all back in later. But our next step is going to be to attach our tread. So you can buy this tread pre-cut to length and drilled. And I recommend doing that. This stuff is kind of a pain to work with. It's annoying to cut. Drilling the initial holes is always hard to get stuck on stuff. But, you know, OK, so now on our wheel, there are a bunch of holes on the side. We need to find the spot where there's 4 holes right next to each other. So there's kind of 2 right here and 2 right here. Everywhere else, it'll be 1 set of holes and continuing. And then in this spot, we have 2. That's the front and the end of our tread. So we'll go ahead and get, especially for the first one, I kind of like to get the screws through the tread a little bit. OK. And then we're just going to screw those in to 2 of the holes and make sure the other 2 are not covered by the tread, right? We need to end on the other set of 2 that's there. We're going to go the long way around. And just like before, I mean, there's nothing really that changed here. We're just redoing it because, you know, we're this far into the video. But it's the same process as what we did on the inverted wheels. The wheels have not changed at all. So we'll get those started. OK, and then get one started in the next hole. We're going to bring it around, do our best to line it up with the next spot. And you really want to try to make sure that this screw is as straight in to that next spot as it can be when you go to screw it in. If you're on an angle a little bit, you might end up cross-threading the hole. It's really easy for that to happen, especially if you didn't buy your treads, but you were making your own. If your hole's a little bit off and you're really fighting to get it lined up, that can cross-thread those holes pretty easily. So make sure you're straight in when you go. It's kind of tricky too, because like it will be a little bit, obviously it'll be harder to tighten it if you're cross-threading, if the screw's not lined up. But we're already screwing through the belt, which already makes it harder kind of to screw these bolts in. So it is a subtle difference there. All right, next one. Get that as straight as we can. And our other one here. All right, seems good. And then the last set here will line up with the holes that we've already got, or the second set of those 4 holes. And you'll know it's kind of, oh, that felt a little wrong. There we go, that's better. You'll know it's kind of good because obviously we'll have that seam, right? Will be, you know, nice and close together. And you might have a small bit of a gap there. That is not a big deal. And the last one, all right. Perfect. All right, wheel tread is on. Next up, we're going to bring back our module. Okay, and we're going to take that. Eventually, this wheel shaft is going to sit in between our forks here. And then we've got this long, this is a quarter 20 bolt. Or quarter 28 bolt that is going to pass through here, and then the nut that goes along with it. Now, if we look pick either fork, the shape here is actually a hex shape. So the nut is going to fit perfectly inside there, and that's going to act as your wrench too. You don't even need a wrench for that side. That's going to, you know, it's going to hold it in place. Okay, so let's go ahead and, oh, my bearing popped out here. Let me put that bearing back in real quick. Cool. So we'll do, the shaft goes through the 2 wheels, drop it down into the forks. Now, when you drop it in, make sure your bevel gear is going to mate with the bevel gear that's here. Okay, so the side with gears have to go together. The side with nothing can go together. So we'll just drop that in to those two spots. And you'll feel it too. Like if you turn this, you should feel kind of the motor and all the gears moving. If you don't feel that, again, double check that your two bevel gears are on the same side and that they're mated together like that. All right, now at this point, right, like we can start this bolt. I'm going to just start it by hand. So I'll get the nut in there. Try again. And I just get it twisted in a little bit by hand. Because if you remember, we had all of these bolts here that we left loose so that we'd be able to get this in. What can happen a lot of times if you tighten those in, this has to spread, these forks have to spread apart just a little for the wheel to drop in easily. So we left them loose for that purpose, but now we got to go back and we got to like Loctite those in so they don't come loose later when we don't want them to. Okay, so, and we can go ahead and tighten them all as we go because all the bolts are in and started. And I do want to get these ones tightened before we do the big cross bolt because that one could pull these holes out of alignment. Okay, get that in. The last one. Okay, and then I'll just go through and make sure they're tight. Give them all a tug on the long side of the hex key here. All right, looks good. Next up, if you find the corner of the module, the corner of this plate, remember we did that one bolt that was a little bit longer, right, so that it's sticking out? Okay, on that bolt, I'm going to add a little drop of Loctite. And we are looking for a hex-shaped standoff. So this is going to be hex-shaped. It's aluminum. And the thread will go right onto that little bit of bolt we have sticking through there. We can tighten that down. And then on this one, if you want, you can, not sure, I don't remember what size this is. Did I guess correctly? No. Did I second guess correct? Yeah, OK. So like a 3/8 wrench will let you kind of tighten that in. Looks good. And then what we're going to do is we're going to take our other plate, okay? And this plate has a smooth side, and it has a side with a bunch of like pocketing, weight-saving, or lightning holes or pockets in it. Now these pockets should be facing away from the other plate. So right now everything is upside down, right? So the wheel is obviously on the bottom. That's the side we should have the pockets on. The pocket should be on the bottom. And this is going to sit right down onto that post that we already have. And we're going to take a 1-inch long bolt. Probably a 1/2 inch would be OK too. This is maybe a little bit overkill. But I think this is the size that came with it. I might have grabbed the wrong size. So if you're not left with a 1-inch long bolt, if you're left with a 1/2 inch long bolt, that's probably OK. But we'll get some Loctite on that. And this is going to go through that corner and screw into that standoff. Yeah, this does feel a little long. Okay, I'm not going to quite tighten that all the way because we have one more to fit on the other side. So I'm going to leave it a little bit loose. Then on the inside corner, so there's one more hole. and it lines up with a threaded hole below on that inside corner. So we have one more spacer that should be the same size. I think it's exactly the same size as, oh no, this is its own size. So this will be the same size as the hex spacer that we used. And this is going to go right on that corner hole. And we're going to take one more, I believe this is a 2 and a quarter. Maybe it, is this 2 1/4 or 2 1/2? I don't have anything else to compare it to anymore. So let me get a tape measure here. This is a 2 1/2, 2 1/2 long bolt. And we'll drop it from the bottom, right, from the wheel side, through the spacer, and we'll screw it into the plate that's there. Okay, and now we can go ahead and make these two bolts tight. Back through and hit it with this one. All right. Okay, and just like the inverted modules, make sure you get grease on them. So on the bevel gears, I think the recommended was the red and tacky, or something that's sticky that's going to stay on them, because they like to really throw that grease out. And then, on the other section where we have just the regular spur gears, you can use lithium, white lithium, or if you have this red and tacky grease, just use the red and tacky grease. And that is it. We are good now with our non-inverted module. Remember, I built one of these on camera. You're going to need to build two. We need two for the front. And remember as well, when you're building them, kind of visualize in your mind, right? We're going to have two of these going across the front of our robot. And you can see for mine, let me flip this around. So now I'm outside the robot and you are inside the robot. So you've got these two on the front, and all of the wires are coming back towards the inside of the robot. All the wires are coming back towards the inside of the robot. So make sure you have yours mounted with the wires like that. If you have to undo it, well, if it's a motor, it's just those two bolts on the motor mount. You can take the whole thing out. You can either 180 the whole thing, or you have to then unmount the motor and rotate it. But if you've got that set up correctly, and you've got your two inverted modules set up correctly, then you are ready for the next video, where we're going to start cutting and attaching them together with some of that 1x2 box. But before we go, we're going to give a special thanks to Argosy. First, Cross the Road Electronics, West Coast Products, Aramco, and Team 302, Lake Orion High School, for hosting our studio.